لازم يطلع دول كام واحد؟
لا.
ليش؟
من البارتيسيبنتس
لا بيطلع له.
حركات أكاديمية أو
بالنسبة للصورة على
بس عليها أوبانال و
طبعا.
Juanel, you can test.
Hello?
Yes, we hear you quite well.
Yeah, but my WebEx has not started. Ah, yes, maybe here. Okay. Okay. Now you can hear me.
Yes, we can hear you.
But you cannot see me, right?
Yes,
okay.
I can see you.
Now you can. Can you see me?
Yes.
السلام عليكم ورحمة الله.
عليكم السلام.
نبدأ على بركة الله. السلام عليكم ورحمة الله وبركاته، وأسعد الله صباحكم بكل خير. يطيب لنا الترحيب فيكم جميعا في مستهل ورشة العمل العلمية عن مرض انفلونزا الطيور عالي الضراوة. هذه الورشة تأتي بالشراكة مع شركة إبراهيم البيطرية، شركة ماس البيطرية، وكذلك مع شركة العلمية المتخصصة في التحضيرات البيطرية. نرحب فيكم جميعا ونتمنى بإذن الله أن الجميع يستفيد من هذه ورشة العمل، وكذلك يعني يهمنا تداخل أو الاستماع إلى مقترحاتكم أو استفساراتكم أو ملحوظاتكم عن طريق استخدام ميزة الشات الموجودة في التطبيق. نشكر لكم جميعا حضوركم، والمايك معك أخوي نواف.
أول شيء بسم الله الرحمن الرحيم. أحب أشكر وزارة البيئة والمياه والزراعة ممثلة في الدكتور علي الدويرد والدكتور عبد الحربي اتاحت الفرصة لإقامة هذه الورشة، كما أشكر شركة باتريك الاستراتيجي لتقديم الدعم للورشة، وأشكر جميع الحضور. لا شك أن الثروة الحيوانية قطاع حيوي مهم، واثبت أهميته جائحة كورونا من خلال الأمن الغذائي. وهدفنا احنا في شركة مال مساعدة الوزارة ولو جزء بسيط لتقديم الدعم لهذا القطاع من خلال الخدمة المجتمعية بإقامة المؤتمرات والندوات. أحب أشكركم مرة أخرى جميعا، وهذه بس نبذة بسيطة عن شركة ماس والشريك الاستراتيجي شركة سيفا لنا.
شكرا لك أخوي نواف. الله
يعطيك العافية.
كما لا يفوتني أرحب بجميع المحاضرين من شركة سيفا. I would like to thank all of you, Dr. Christophe, Dr. Guanel, Dr. Hamis, Dr. Hazem, Dr. Ala, for participation in this workshop. نتمنى إن شاء الله بإذن الله التوفيق للجميع. الكلام مع دكتور حازم. تفضل دكتور. دكتور علاء.
السلام عليكم ورحمة الله.
السلام ورحمة الله.
في البداية نيابة عن شركة سيفا وبالأصالة عن نفسي أحب أشكر الدكتور علي لإتاحته الفرصة لينا لأن احنا نقدم الخدمات اللي هي فعلا مركز ثقل سيفا عالميا، ألا وهو إن احنا دائما بنركز على عملائنا وبنشوف إيه المشاكل اللي ممكن تواجههم. الدكتور علي من خلال رؤيته الشاملة للمملكة وللوضع الوبائي في المملكة، وخاصة إن احنا داخلين على فترة الشتاء، فقرر إن هو يعمل ورشة تثقيفية تختص بمرض إنفلونزا الطيور. وإحنا حبينا نشارك جميع الحضور وجميع مربي الدواجن وشركات الدواجن الموجودة في المملكة الصناعة كاملة خبرات شركة سيفا العالمية في مرض إنفلونزا الطيور. الورشة النهاردة هي ورشة غير دعائية بالمرة، لن يذكر فيها أي شيء، هي ورشة تثقيفية علمية بتركز على كيفية التحكم في مرض إنفلونزا الطيور، كيفية التعامل معاه ووبائيته ومدى ضراوته، وإزاي إن إحنا نقدر نتعامل معاه في ظل الظروف الموجودة. فأحب أشكر الدكتور علي الدويرج لإتاحة الفرصة دي لينا، وأحب أشكر أستاذ نواف إبراهيم صاحب ومدير شركة ماس للخدمات البيطرية لحرصه الدائم على تقديم أعلى مستوى من الدعم الفني للسوق البيطري السعودي في المملكة. أشكركم جميعا. المايك معك يا دكتور علي.
شكرا علاء. طبعا هذه الفعالية تأتي ضمن يعني جهود الوزارة للشراكة بين القطاعين العام والخاص لتحقيق المصلحة العامة للقطاع Private Public Partnership، وهي بإذن الله انطلاقة للمزيد من الشراكات والتعاون بين الحكومة أو الوزارة وكذلك مؤسسات القطاع الخاص لتعظيم الاستفادة من الخبرات والمقدرات الموجودة لدى كل من الطرفين ولتحقيق المصلحة العامة والمتمثلة في تنمية القطاعات بشكل عام. أرحب وأكرر ترحيبي في الجميع. أنا ودي أستهل اللي هو الفعالية لو تسمح للجميع، راح نتكلم عن قطاع في المملكة العربية السعودية وجهود الوزارة في السيطرة على اندلاعات المرض إنفلونزا الطيور التي حصلت في السنوات الأخيرة، واللي الحمد لله تمت السيطرة عليها في المملكة. فراح أشارككم الآن بعض المعلومات عن مرض إنفلونزا الطيور في المملكة أو القطاع بشكل عام، وكيفية أنها قدرنا ولله الحمد في المملكة العربية السعودية أن نقضي على هذا المرض وأن يكون تحت السيطرة.
دكتور علي اسف مقاطعة حضرتك، معلش انا بتبدا البرزنتيشن لان في بعض الزملاء من الاتنديز بيقولوا ان الصوت مش واصلهم، فنستأذنك نتأكد إن الناس سامعين حضرتك كويس من خلال الشات بوكس. في كذا شكوى بتقول إن صوتنا مش واصل للمستمعين. تمام.
الصوت واضح؟
الصوت واضح حضراتكم؟ قلنا في الشات بوكس سامعين كويس أو لأ؟
الصوت واضح دكتور حازم.
تمام.
واضح الصوت؟
اتفضل حضرتك.
دكتور علي
نعم. طبعا زي ما قلنا انا هتكلم بدايه عن القطاع في المملكه العربيه السعوديه. قطاع الدواجن في المملكه العربيه السعوديه يشهد له الحمد نمو واضح، وايضا التوجه العام لصناعه الدواجن في المملكه العربيه السعوديه يعني يتطلع الى النمو ولتحقيق الاكتفاء الذاتي من المنتجات. الحمد لله بشكل عام في المملكه العربيه السعوديه معظم الانتاج الدواجن عبر مشاريع متخصصه حديثه، ونسعى الى ان تكون مستدامه. هنا بعض الاحصائيات عن توزيع الدواجن في المملكه السعوديه. النسبه العظمى هي مشاريع بياض، وتليها اللاحم ثم المشاريع الاخرى. المملكه العربيه السعوديه تسعى ضمن رؤيه 2030 لتحقيق الاكتفاء الذاتي من منتجات الدواجن. كما نسبه الاكتفاء حاليا هي 16%. عفوا الاخوان يسكرون انها حاليا نسبه الاكتفاء الذاتي من البيض 116% من احتياج المملكه، وراح نسعى باذن الله للابقاء على هذه النسبه بحلول 2030 باذن الله. ايضا لدينا نسبه اكتفاء ذاتي اللحوم ب 65% من الاحتياج بما يوازي 900 ألف طن. نسعى باذن الله في حلول 2030 الى ان تكون 85% من احتياجات المملكه من لحوم الدواجن مغطاه بما يوازي 1275 طن. تتبع الوزاره لذلك عده استراتيجيات التحول في الزراعه والتربيه التقليديه وتحسين الوراثي وتعزيز صحه الحيوان وترشيد المواد الطبيعيه واستخدام الادوات مثل ادوات برنامج الاعانات الزراعيه لدعم هذا القطاع بشكل مستدام. برنامج قطاع الدواجن في المملكه وهو عباره عن برنامج دعم حكومي للاعلاف المقدمه للمشاريع، بلغ متوسط الدعم الحكومي لهذه المشاريع بشكل شهري ما يوازي 50 مليون ريال ولله الحمد. لذلك ايضا ضمن برنامج رؤيه المملكه 2030 نسعى لتحقيق العديد من المؤشرات لضمان استدامه هذا القطاع من خلال تطبيق مشاريع الثروه الحيوانيه لبرامج الجوده الشامله، والتي تعنى بتطبيق جميع المعايير الضروريه للجوده الشامله في كل مراحل الانتاج، بدءا من سلسله التوريد الى الانتاج داخل المشروع ومن ثم الى الانتقال. ايضا نسبه الامراض الحيوانيه والسمكيه المسيطر عليها في المملكه نتطلع الى ان يكون 100% بحلول 2030 تكون تلك الامراض تحت السيطره. ايضا نسعى الى تحسين تغطيه الثروه الحيوانيه بما فيها الداجنه بالخدمات البيطريه عاليه الجوده للوصول الى نسبه 80% باذن الله بحلول 2030، وكذلك ادخال التقنيات الحديثه للانذار المبكر والتحكم في الامراض الحيوانيه بنسبه 80% بحلول عام 2030 باذن الله. استمعكم راح اوقف العرض دقائق وساسالكم باذن الله. دور وزارة البيئة والمياه والزراعة في الرقابة الحكومية على مشاريع الدواجن في المملكة العربية السعودية هو ينطلق من عدة أنظمة أساسية اللي هي نظام الثروة الحيوانية ونظام مزاولة المهن الطبية البيطرية ونظام الحجر البيطري والرفق بالحيوان في المملكة. نص نظام الثروة الحيوانية على أن الوزارة مسؤولة عن اتخاذ كل التدابير لمكافحة أي مرض من الأمراض المعدية والوبائية التي تصيب الثروة الحيوانية، ومنها مرض انفلونزا الطيور عالي الضراوة. الوزارة تصدر لذلك العديد من الأدلة التوجيهية والإرشادية لمشاريع الدواجن، منها دليل الأمن الحيوي في مشاريع الدواجن المحدث، وكذلك دليل تقييم أو الجودة الشاملة للمشاريع البايو سكيورتي ستاندرد لتطبيقها، وهي عبارة عن أداة لمساعدة المشاريع على تطبيق معايير الأمن الحيوي لحماية تلك المشاريع والصناعة بشكل عام من أي مخاطر مرضية محتملة. أيضا الوزارة والمملكة تلتزم بالاشتراطات والمعايير الدولية المنظمة لإجراءات الأمن الوقائي والتي تصدر من الهيئات مثل منظمة صحة الحيوان العالمية، وكذلك منظمة الأغذية والزراعة للأمم المتحدة. كما أن الوزارة تلتزم أيضا بالشفافية المطلقة في الإبلاغ عن أي حالات اندلاعات وبائية لمرض انفلونزا الطيور عن ضابط أو مكتب الاتصال الوطني مع المنظمة والتي تحتويها وزارة البيئة والمياه والزراعة، والإبلاغ عن أي حالات انفلونزا الطيور عالي الضراوة تحدث في المملكة. أيضا للوزارة دور كبير في الرقابة على مشاريع الدواجن من خلال ضمان التزام تلك المشاريع بتطبيق إجراءات الأمن الحيوي الصادرة من الوزارة، وكذلك التأكد من أن تلك المشاريع وشركائنا في تلك المشاريع يلتزمون بتلك الإجراءات. أيضا الوزارة تقوم بإغلاق بالتعاون مع جهات ذات العلاقة بإغلاق أي مشاريع دواجن عشوائية قد تؤدي إلى الإضرار بصناعة الدواجن في المملكة على المدى القريب أو البعيد. أيضا كما يقوم فتش الوزارة بجمع عينات من مشاريع الدواجن للتأكد من صلاحيتها وسلامتها للإنتاج والاستهلاك الآدمي. وبالنهاية أيضا تقوم بعمل المسوحات الدورية لجمع عينات من المشاريع الدواجن للتأكد من خلوها من أي مسببات مرضية وبائية قد تشكل خطرا على الصناعة، سواء من خلال المسح الروتيني العشوائي للأسواق العشوائية أو المشاريع، أو أيضا اللي هو الحالات الإيجابية لا قدر الله في حال حدوثها في مناطق المملكة المختلفة، والتي تقوم المشاريع مشكورة بإبلاغ الوزارة عنها لاتخاذ الإجراءات الكافية. أيضا تقوم الوزارة بتأكد بالتزام العاملين بأدوات السلامة المهنية المناسبة، وبطبيعة الحال في حالة حدوث أي حالة إصابة بالمرض في مناطق في أي منطقة من مناطق المملكة، تقوم الوزارة باتخاذ تطبيق خطة الطوارئ على تلك المناطق من خلال اتباع سياسة الإعدام الكلي لمناطق الإصابة والمناطق المحيطة، وتطهير تلك المشاريع المصابة للتأكد من أن هذه المشاريع قد تشكل بؤرة خطيرة على صناعة الدواجن بشكل عام. إجراء صارم وراح يكلمنا عنه الدكتور سند مدير عام إدارة تقييم مخاطر الثروة الحيوانية، وأيضا مركز التحكم والسيطرة على الأمراض الحيوانية، بكيفية تعامل الوزارة الصارم مع أي حالات اندلاعات انفلونزا الطيور في المنطقة للتأكد من القضاء بأسرع وقت ممكن وبأعلى فعالية ممكنة على أي اندلاعات. أيضا التأكد من أن هناك الإجراءات الأثر عدم حدوث أي آثار بيئية نتيجة تلك لإصابة تلك المشاريع من خلال التخلص من الطيور المصابة بالطرق الآمنة بيئيا وصحيا على المنطقة. طبعا كما يعلم الجميع أن المملكة العربية السعودية تعرضت قبل عدة أعوام لمرض انفلونزا الطيور عالي الضراوة H5N8، والذي تسبب بخسائر كبيرة لقطاع الدواجن وخاصة الدجاج البياض وكذلك الأمهات، وتسبب في تبعات كثيرة على القطاع. تعاملت انفلونزا الطيور مرض عالي الضراوة من الأمراض الواجب التبليغ عنها حسب نظام الثروة الحيوانية اللي تكلمنا عنه قبل شوي. أيضا تم إدراج مرض انفلونزا الطيور ضمن الأمراض المزمع يعني السيطرة عليها بشكل كامل بحلول 2030 من خلال تحسين المعايير الأمن الحيوي في مشاريع الدواجن وكفاءة الإبلاغ، وكذلك التعاون المشترك بين القطاعات الحكومية والخاصة للقضاء على هذا المرض. طبعا المملكة تشترط أن تكون جميع الطيور الواردة إلى المملكة سواء فطرية أو مستأنسة من دول خالية من مرض انفلونزا الطيور، وأيضا تقوم بسحب عينات من المنافذ التي تصل إليها تلك الطيور للتأكد من خلوها من مرض انفلونزا الطيور في مختبرات الوزارة. تقوم أيضا المختبرات البيطرية في الوزارة بتشخيص مرض انفلونزا الطيور، شبكة من المختبرات البيطرية حول المملكة. الإرشاد البيطري يقوم بحملات توعوية عن المرض للمشاريع في المناطق الأكثر خطورة. تقوم الوزارة كما أسلفت بمسح دوري عشوائي للمشاريع والتربية الريفية والطيور الفطرية عن المرض في المملكة. هذه الإجراءات التي اتبعتها المملكة أو اتخذتها الوزارة لمكافحة المرض في المملكة تشكيل لجان الطوارئ والإعلان الرسمي عن الإصابة بانفلونزا الطيور من منطلق الشفافية المتبعة في الإفصاح عن أي حالات إصابة في الدواجن، تواصل مع الجهات الحكومية وأصحاب العلاقة لاتخاذ التدابير اللازمة لمحاصرة بؤر الإصابة، أيضا تشكيل لجان التعويض في المناطق، التواصل الفعال مع المشاريع، وأيضا ضبط حركة التنقل بين المناطق ومن ما بين المناطق المتضررة والمناطق السليمة، وكذلك على مصانع الأعلاف وقف إجراءات استيراد الطيور من الدول التي قد تشكل خطورة على الصناعة في المملكة، اتخاذ الإجراءات التنفيذية لخطة الطوارئ في المملكة. راح نتحدث عنها بمزيد من التفصيل مع الدكتور سند الحربي في محاضرة لاحقة للحديث عن الإجراءات بالتفصيل المتبعة لمحاصرة أي بؤرة إصابة في حال حدوثها لا سمح الله. هذه بعض الأرقام عن اندلاع انفلونزا الطيور التي حدثت خلال عام 2018. كان بلغ إجمالي الإعدامات كما ترون أكثر من 9 ملايين طائر في المملكة بشكل عام، كانت في المشاريع وفي التربية الريفية، حيث أن دائرة الإعدام تمتد إلى 5 كيلومتر حول أي بؤرة مصابة. كانت معظم المناطق سجلت حالات إصابة ما عدا 4 مناطق أو 5 مناطق إدارية في المملكة، وكانت النسبة الكبرى في منطقة الرياض ذاك، وتم تحكم بالمرض بشكل كامل ولله الحمد. تم أخذ عينات إيجابية من الطيور البرية والمهاجرة للتأكد من أن تكون مصدر لإصابة المشاريع بالإصابات، وأثبتت بعض النتائج إيجابية بعض الطيور البرية المستأنسة في المنطقة أو المهاجرة عبر حدود المملكة. كما تعلمون أن المملكة العربية السعودية تقع على مسارات عدد من الهجرات العالمية للطيور، ولكن ولله الحمد جودة النظام الصحي البيطري في المملكة والتزام المشاريع بالإبلاغ وكذلك التعامل الفعال والبناء للوزارة وللقطاعات الحكومية كافة لمحاصرة المرض أدى إلى تقليل مخاطر انتقال المرض عبر الطيور المهاجرة إلى الصناعة بشكل عام. هذه أيضا بعض الإحصائيات عن الإصابات في المملكة وإجمالي عدد العينات التي جمعت حوالي 14,000 عينة، حالات الإيجابية كم، المشاريع المصابة بشكل عام. لو نتكلم فقط عن الآثار الاقتصادية للاندلاع الأخيرة، كان نفوق عدد كبير من الدواجن، تم إعدام ملايين الطيور بسبب الإصابات في المشاريع والتربية الريفية. للأسف كما يعلم الجميع أنه قامت الدول بحظر استيراد الدواجن ومنتجاتها من المملكة بسبب تلك الإصابة آنذاك. توقفت عدد من المشاريع الإنتاجية الهامة، وخاصة مشاريع الإمداد مثل مشاريع الأمهات والتي أصيبت بالمرض، وأيضا مشاريع البياض بشكل كبير. تم إقفال أسواق الطيور بالمملكة. هناك تكاليف كبيرة على الدولة صرفتها كتعويضات لأصحاب المشاريع التي تم إعدام طيورها بسبب المرض، ولكن هذا من دعم الحكومة لاستدامة القطاع للتأكد من أن تلك المشاريع بقدرة يعني ستستطيع القيام من جديد والقيام بدورها في تعزيز الأمن الغذائي وتوفير منتجات دواجن في المملكة. أيضا تكلف عمليات الإعدام والتخلص الصحي للدواجن. في مرحلة بسيطة ارتفعت أسعار بعض منتجات الدواجن كتداعيات لهذه الإصابة. أيضا خسائر الشركات الخدمات اللوجستية، شركات المستحضرات، شركات الأعلاف، شركات التسويق ونحوها بسبب تلك الاندلاعة. تم تكوين المجلس البيطري للدواجن واللي يتكون من ممثلين من الوزارة والقطاع الخاص، ويهدف إلى تنسيق التعاون بين الوزارة والقطاع الخاص في مكافحة الأمراض، إيجاد حلول للمشاكل الفنية التي تواجه صناعة الدواجن، ورفع كفاءة الإنتاج، وفتح قنوات تواصل بين القطاعين العام والخاص لتحقيق التكامل في التصدي لأي مخاطر قد تؤدي إلى الإضرار بصناعة الدواجن في المملكة. بشكل أخير، وزارة البيئة والمياه والزراعة تعمل من أجل استدامة قطاع الدواجن والزهارة. هذه رسالة لجميع أصحاب المشاريع أنهم يكونون عونا للوزارة لتحقيق تلك الأهداف من خلال التعامل الإيجابي والتفاعل الإيجابي والإصلاح والشفافية والتعاون بكل إيجابية وتفاني مع جهود الوزارة لمحاصرة هذا المرض، والتأكد من تحسين جميع معايير الأمن الحيوي لتتوافق مع المعايير التي تعتمدها الوزارة لحماية تلك المشاريع أولا وأخيرا من أي مخاطر لمرض انفلونزا الطيور أو أي أمراض وبائية أو معدية أخرى. طبعا هذا الرقم المجاني المخصص للطوارئ للإبلاغ عن أي حالات إصابة أو أمراض في المشاريع قد تكون معدية أو وبائية وتؤدي لإضرار للقطاع. أتمنى من جميع الحضور الاحتفاظ بهذا الرقم لا قدر الله في حالة أي طوارئ أو حدوث أي مشاكل مرضية أو وبائية. 800 247 4 أصفار، وسيتم التعامل بمنتهى السرية مع أي بلاغات، والتعامل أيضا معها بكل جدية في حالة كونها خطرا على المشروع أو المشاريع الأخرى القريبة. أشكر حسن استماعكم، والآن المايك معك أخوي حازم. تفضل أخوي حازم.
شكرا جزيلا دكتور علي، واحب ارحب بحضراتكم مره ثانيه، وانوه في بدايه اليوم تاني ان احنا عندنا لينك ايقونه تحت فيها Q&A. اي حد عنده اي سؤال لاي من السبيكرز هيكتب السؤال بتاعه وموجه لمين من السبيكرز. في نهايه المحاضرات احنا ان شاء الله نوجه الاسئله للمحاضرين. هنبتدي اليوم النهارده مع دكتور كريستوف لبان. Dr. Christophe has been graduated from French Veterinary University in Lyon in 1993 and completed his education and specific training on virology, immunology, and medium pathology in Lyon. And he started his professional career in poultry biologicals right from the beginning, and he first joined Romerier, which is later became Muriel, and then now it is Boehringer Ingelheim. He has held several positions in the quality control, regulatory affairs, and R&D. In 2002, he joined Seva Santé Animale as an international technical manager for the poultry team. After 4 years in the position, he moved to more operational responsibilities as poultry range manager for an area covering Turkey, Middle East, and whole Africa. Afterwards, he held position in global veterinary service manager and knowledge manager for poultry biologicals. From the early 2020, he has been appointed as global scientific director for global vaccines, and responsibility includes providing scientific expertise in the field, managing scientific investigation studies, and networking with global and key opinion leaders. Christophe will start his presentation. في نهاية المحاضرة أنا هعمل ربط بالعربي بسيط. So Christophe, please, the stage is yours.
Okay, thank you very much for the kind introduction. I'd like first to thank very much the Saudi Ministry of Environment, Water and Agriculture for organizing this workshop on highly pathogenic avian influenza. And so my name is Christophe Casaban. I send you my greetings from France. I would love to be with you in Riyadh to have more interaction, more discussions, but unfortunately, because of the current sanitary situation, we have to stay a little bit on the remote conditions. But anyway, I hope all of you are keeping fine and safe and healthy with your family and with your business as well. So I'm going to share my screen now. I hope you're going to see it properly. So my talk today will be about describing the disease, I mean the clinical signs of highly pathogenic avian influenza, as well as giving you some clues on differential diagnosis. Just to set the scene a little bit, we have to acknowledge that there are plenty of different clinical signs that can be elicited by highly pathogenic avian influenza infection. And none of them is typical. None of them is pathogenic where you can for sure state, oh, this is highly pathogenic avian influenza. So there are plenty of other conditions that may look like HPAI. But my objective today is to have a kind of review together on what should be the very first warning signals to you when observing your birds in the farms, in the houses, in order to put HPAI among your list of differential diagnosis. I think that's very important because, as we know, the earliest we apply some control interventions, the best we minimize the losses. So just as a quick introduction on the virus itself, Dr. Gwenaël will give you some more hints on that. But as you may know, this is a quite complicated virus, which contains on its surface two types of antigens, namely the hemagglutinin and the neuraminidase. And actually, what matters for my talk here is the hemagglutinin, because that's the piece which will help the virus to attach to the target cells and tissues in the organism. That's the main, what we call, virulence factor of the virus. And interestingly, that's also the main protective immunogen. In other words, the bird will develop immune reaction towards this hemagglutinin antigen. So that's obviously a key part of the virus for either classification or prevention policies. There are several subtypes of the virus based on the hemagglutinin sequence. Again, Dr. Gwenaël will come back on that. What I would like to just to remind you here is that among the various subtypes that are described, only the H5 and the H7 are so-called notifiable to the World Animal Health Organization. Acronym is OIE. It means that all the other subtypes of avian influenza, I mean, neither H5 nor H7 are not notifiable. So we've got two completely different policies, two completely different control interventions. So my talk today and this workshop today will deal only with these notifiable avian influenza and especially their highly pathogenic pathotype. So what's the difference between low pathogenic and highly pathogenic type of virus? We have to understand that when the virus is building up, first this hemagglutinin, you remember that's the key virulence factor of this virus, is first produced as a HA null or HA0, which is an inactive hemagglutinin. And to become active, this hemagglutinin needs to be cut, needs to be split into two different pieces, two different segments, the subsegment 1 and the subsegment 2. And this cut is done by the protease of the host. It's done by the protease of the body of the chicken. And actually, depending on the amino acid sequence on that cleavage site of the inactive hemagglutinin, you're going to have either a monobasic amino acid sequence at that cleavage site, so basically only one basic amino acid, which means that this inactive hemagglutinin can only be cleaved by trypsin. Where is trypsin? It's located only in a few places in the body, so there will be a quite localized, a quite restricted replication area of this virus. Namely, it's going to be focused on the intestinal tract and the respiratory tract only. These viruses are called low pathogenic. On the opposite, you see here in the bottom of my table, if this cleavage site contains multiple basic amino acids motifs, multiple means higher than one, and these basic amino acids are either arginine or lysine, and you can have any of these combinations at this location. In this way, in this case, this particular virus can be cleaved by any type of protease, like what we call the furin-like protease, which are present everywhere in the body. By this way, the virus can have a systemic infection, meaning that it's able to disseminate throughout the body because this hemagglutinin can be cleaved by any single host protease of the body. So this is why this type of virus is highly pathogenic, because the infection results in such a high amount of signs and dissemination in the body. All of these viruses come from some reservoirs. And we know that especially the wild migratory birds, but as well as backyard birds, they play a very significant role as a reservoir for all types of avian influenza viruses. And they are very regular circulation throughout the countries, even throughout continents, because of the migration of these wild birds. And from time to time, you see my arrow is getting narrower and narrower. From time to time, because of some contacts with backyard birds or semi-intensive chickens, there is an introduction into the industrial poultry production. And this may induce, in some cases, an outbreak of low pathogenic avian influenza. Remember that the vast majority of avian influenza viruses are low pathogenic ones. But because this virus is able to mutate, from time to time, this low pathogenic avian influenza virus, provided that it is of the H5 and H7 subtypes, and provided that this cleavage site bears these multiple basic amino acid motifs, then it's going to mutate into a highly pathogenic avian influenza type. As of today, this change from low to high pathogenicity has been observed only with H5 or H7 subtypes. Up to my knowledge, there is no clear explanation so far why the other avian influenza virus subtypes don't show the same ability as H5 or H7 do. Perhaps in the future we'll get some explanation, but as of today, it's just an observation. So as I mentioned, definitely wild birds, migratory birds play a clear role in the perpetuation, in the persistence of avian influenza viruses as a whole in the nature, and as a permanent threat towards the domestic poultry production. An interesting example for that's directly is an issue for Saudi Arabia is the risk related to the bustards, which are, as you know, used for falcons. That's very popular in Saudi Arabia. And as you can see, a little bit more than 10 years ago, there has been this very nice description on how imported bustards into Saudi Arabia brought with them H5N1 isolate. It turned out that it's very close to a Kuwaiti strain of H5N1. And these bustards showed a quite high rate of mortality. But before dying, they were used as a feed for falcons, of course. And they also were able to transmit this HPAI virus to these falcons. So there was also a very high mortality rate into these falcons. So that's definitely a clear risk towards this business, I would say, in your country. Coming back to the industrial chicken production, as we know from the first index case where we have infected premises, then the methods of spread, I would say, are quite typical, quite usual for fast infective, fast contagious diseases. Namely, the spread can be easily done first by people, by vehicles, by feed, by improper disposal of carcasses, these kind of things. And Dr. Jaime will come back on that at the end of this workshop, where the biosecurity plays obviously a very, very critical role here in order to contain, in order to restrict this type of spreading risk. Okay, now, as I mentioned in my introduction, my aim today here is going to share with you plenty of pictures which are depicting highly pathogenic avian influenza infection in chickens, and only HPAI infection. There was no co-infections there. So just for you to bear in mind, hopefully, these pictures, just in case by coincidence you observe, let's say, similar signs in your operations, in your houses, again, is to have HPAI among your list of differential diagnosis, and not to miss this, because that's obviously extremely important. Just to start, let's say, from probably the most striking sign that should definitely suggest you highly pathogenic avian influenza. Of course, this could also be velogenic Newcastle, but definitely HPAI should be on top of your mind in your diagnostic list. It's because it's able to induce such type of sudden, massive mortality, and the remaining birds show a very high morbidity into a house. And usually, again, that's very sudden. Within a few days, the entire flock may be completely dead, like this. So again, keep in mind that HPAI is able to induce usually a very high, massive, and sudden mortality. So obviously, you will have first to check on the management whenever there has been any mistake or issue, like electric shutdown in the house for hours, these kind of things. But as soon as you succeeded to rule out these technical issues, then we have to think about infections and fast spreading infections and very, very acute infections, namely HPAI first. As you can see, and I will come back on that in the next slides, usually the carcass is quite congested, is very red, because this virus is able to invade the body and is able to attack in particular the blood vessels that will be much more permeable. So that's why you've got a very strong congestion. You got a very strong invasion of the body by blood fluid. So this should be definitely an alert sign. Before we come up to this, let's say, dramatic final stage, some very first warning signs could be the following. When you see birds like this showing a kind of depression, huddling, this bird is evidencing fever. So there is a systemic infection going on in the body of this bird. So definitely, this is one of the very first signs of HPI, and among very important signs that we have to keep an eye on and spend time to observe the birds. As you can see here in the dorsal neck of this bird, there are ruffling on feathers. That's again showing depression, discomfort, and fever. In addition to that, sometimes, because we may also have some nervous disorders, there is a reluctance to stand or a reluctance to move. It's not that frequent as compared to Newcastle disease, but it may happen. And of course, and I will come back on that, as you can see here already on the comb and the wattles, they don't look normal at all. They're already showing some hemorrhages, some ecchymotic hemorrhages, and even some cyanosis. Just to have a closer look at this slight nervous disorder, you can see here there is a lack of the perching reflex when you put your finger under the feet of this bird. This is a picture perhaps less common in Saudi Arabia, but at least it's coming from France when we were hit by HPAI. So this is a swan, wild swan, of course, in a pond, and it was showing definitely, as you can see, some torticollis. Again, this is not as frequent as routine as we can observe with neurotropic Newcastle disease, but again, this is possible with HPAI as well. Perhaps not with all isolates, with some of them, but definitely this is part of the overall symptomatology. Coming back to the overall depression of these birds and this huddling behavior, again, ruffling on feathers in the dorsal neck, and on top of that here, as you see, there are drooping wings. So this bird is definitely very weak because it's experiencing fever. And here, if you can see here on the bottom, there are already some sloughing of the intestinal mucosa. So you've got already some orange feces, just because that's the intestinal mucosa that is put out of this bird. It's a very early sign, because later on, as we're going to see in the next slides, we will see some more, let's say, typical diarrhea signs, which will turn into greenish and then white. So this orange color is definitely one of the very first signs in the very first days of the infection. Remember, when these birds are overall depressed, there can be also some signs of just sleeping. And because they are depressed, because they feel discomfort, because they sleep, one of the very first signs will be a drop in feed intake, a drop in water intake. So please watch very carefully your record system on feed consumption, on water consumption, because any drop in these normal, let's say, rates should definitely be a very early signal that something is going on in your houses. So now let's have a closer look at different parts of the body. Here, I guess you can already easily observe that there is some edema around the eyelids and the subcutaneous tissues, as well as some beginning edema in the comb and in the wattles. That's just a top view of this beginning of edema of the comb and of the comb, especially here of the comb, and congestion as well. Remember, this virus is able to invade the blood vessels very, very strongly. So next, after the congestion, you will be able to observe that the comb is becoming dry. Remember, there is a drop in water intake. So overall, these very, let's say, unfeathered parts of the body will very quickly become dry and wrinkled like this. So that's again a sign that's the beginning of the infection. And I don't know if you can observe already at this stage, there is very slight pinpoint signs of hemorrhages that are starting in this comb. That's probably a later stage where we start noticing some necrosis and cyanosis here in the tip of this comb, and probably a second one here. So there is a progressive stage of acute inflammation, congestion, and later on cyanosis and necrosis of these parts of the body. That's a later stage. As you can see, the comb is still very much dry, is thick, and there is edema, but you've got definitely a beginning of strong hemorrhages and I would say cyanosis. You can see here, both on the comb, on the wattles, edema, hemorrhages, and cyanosis. That's just a closer look of these wattles with definitely some ecchymotic hemorrhages and congestion, and later on, edema, ecchymotic hemorrhages, and cyanosis. Again, a very late stage, very strong dehydration of the skin, very strong cyanosis, and still the bird is still not dead at this stage. Huh? That's quite interesting. So, just to conclude on this front picture, a common wattle showing acute edema. They are swollen, they are hemorrhagic, the skin is dehydrated, and overall, because there is a face edema, the head becomes a little bit square like this. So that's not typical for HPAI. That could be some other respiratory disease like Pasteurella multocida, fall cholera, like infectious bronchitis, like coryza, like swollen height syndrome. But again, HPAI is definitely one of these conditions to bear in mind. And interestingly, if you run an incision into this comb, you will be able to observe beyond this edema and hemorrhages that there is also an edema of the subcutaneous tissue, where you can observe here in the middle a very thick, wet, and gelatinous material that is inside the comb, and the same in the wattles. The wattles are congested, are edematous, and here you can very clearly see this gelatinous material that is swelling the wattle itself. Now moving a little bit to the respiratory tract system. Again, edema around the eye with the eyelids that are half closed, and it gives the bird an almond shape of the eye. You will observe this very, very typically with laryngotracheitis as well, with swollen height syndrome, with mycoplasma, but definitely that's part of the respiratory tract infection. Also, obviously, some breathing difficulties with this open mouth breathing. And here, by cutting on this eyelid palpebra, you will be able to identify a very strong congestion and some hemorrhages on the mucosa of this eyelid. So you see, besides, let's say, strong mortality rate, some early signs of the disease are skin dehydration, swelling, and hemorrhages, and later on necrosis and cyanosis of the comb, of the wattles, and upper respiratory tract disorder and distress signs. Now let's move to other parts of the body. What you can also observe with highly pathogenic avian influenza is in these legs, and especially the skin of these legs, some subcutaneous hemorrhages like this. This is a later stage with a little bit more intense, more severe ecchymotic hemorrhage in these feet, and that's a later stage where on top of the hemorrhage in these shanks in the skin, you also start to observe an edema here directly in the feet, in the dorsal, in the tarsal pads. So that's quite suggestive for HPAI, this one. Now, let's move to the internal organs, internal tissues. Remember, this virus is able to invade any part of the body. So as a result, you may get plenty of different clinical signs because any type of tissue, any type of organ is able to be infected and to be damaged. So in terms of digestive tract, it may definitely induce some disorders in the enteric tract that will start with a mild soiling of the feathers around the vent like this with a mild diarrhea. Of course, in the later stage, as you can see here, the vent is extremely dry, is soiled by feces, as well as the skin is extremely congested, is extremely reddish because of the subcutaneous congestion on the body. Remember, after the first sloughing of the mucosa of the intestine, which will give you this orange color, one of the first signs of acute diarrhea will be this greenish color just because of excess of bile that is excreted by the birds. And actually, very, very quickly, is going to turn into white because on top of that, you will have an excess of urates, of uric acids that will stain these feces into white. So that's another picture showing you how the cloaca can be severely damaged, congested, hemorrhagic, as well as the skin, the ventral skin. That's just another view about this. And you've got also some lack of feathers here. Of course, here these were very, very old birds, so there was some molting on top of that. But there is definitely a very strong acute hemorrhage in the skin. So that's definitely part of the signs of HPAI. Not only the skin, but also the subcutaneous connective tissue is severely inflamed. And as a result here, you've got some edema with some gelatinous material directly under the skin as a sign of generalized inflammation of the body. Now let's look at some organs in particular. You recognize here, obviously, the trachea from outside, where we can already observe a very diffuse, very broad hemorrhage and congestion, but already some spots of very acute petechial hemorrhages in the mucosa of this trachea. When we open this trachea, that's probably the very early stages. We are able to observe, obviously, some beginning of hemorrhages, as well as some catarrhal here exudates in the lumen of the trachea. So that obviously explains the beginning of breathing difficulties of these birds. In a later stage, again, just before opening the trachea, and here that's the larynx, you can easily observe a very strong inflammation, strong tracheitis over here. And when you open this, that's extremely inflamed. So again, this should also suggest you pathogenic Newcastle disease, maybe some acute stages of infectious bronchitis. So that's not typical for HPAI, unfortunately, but that's definitely part of the signs we can observe. That's another very strong inflammation of the trachea here. Again, as you can see, some very strong hemorrhages everywhere and around the trachea. When we go to the digestive system, here that's just the coelomic cavity. When we open it, as you can see here, there are some pinpoint petechial hemorrhages in the abdominal mesenteric fat here, and as well as on the outside serosal surfaces of the intestine. So again, remember, a very massive, diffuse hemorrhagic signs throughout the body. Here, I'm really glad to show you this picture. That's the pancreas, which shows some hemorrhages, as you can see here, all along the organ. And that's probably one of the few typical signs of highly pathogenic avian influenza. So remember, hemorrhages in the pancreas, HPA most likely. So that's very, very important to bear in mind. If we go a little bit now down to the digestive system, that's the crop mucosa, where we can observe already some erosions, some ulcers, some hemorrhages around this crop. Now, that's the proventriculus. Even from outside, there is some hemorrhages in the width of the mucosa here. And just as a remark here, you've got also some hemorrhages in the intercostal spaces. Now, when you open this proventriculus in the very early stages, you will be able to observe these very small pinpoints, petechial hemorrhages here in the junction, either with the gizzard or with the esophagus here. In a later stage, you should be able to observe these pinpoint hemorrhages on the apex of the glands of the proventriculus. So that's also pretty typical for HPAI infection. Remember that. Just a few other pictures. The lungs can be also extremely severely affected. Like this one, you can see very strongly hemorrhagic pneumonia. We can also observe some hemorrhages here on the epicardial serosa, as well as here on the basis of the great vessels here. You can see here the arrows. Just don't keep this in mind, because that's just due to this to the euthanasia of these birds. When we see as a closer look, you can see here these hemorrhages on the epicardial fat around the heart. Another one, not typical, definitely for HPAI, but again, it's part of the overall clinical symptoms. That's the liver, which shows some swelling, some discoloration. There are blunt edges. It's very pale, and it's also hemorrhagic, as you can see here. And same for the kidneys. They are swollen, they are congested, they are hemorrhagic, and on top of that, as you can see here, you've got some urates deposits in the renal tubules as well as in the ureters. So obviously there will be other conditions to rule out if you observe this type of signs. But again, HPAI should be one of them. And finally, the ovary can also be severely affected here. As you can see here, there is a very strong atresia of this ovum, of this follicle, and there are also some very strong hemorrhages of some other follicles. That's probably a more severe picture of the ovary with, again, congestion. Most of the follicles are hemorrhagic. Some are already showing some signs of atresia. There is no mature ova, and there is even some fat here, and there is some abdominal, some egg yolk peritonitis around this. And remember, one of the consequences of that in layers and in breeders is obviously a drop in egg production. Not only a drop in production quantity, but also a drop in quality, with misshapen eggs, with soft-shelled eggs, and in brown genetic lines, a discoloration, very strong discoloration of the eggs. And finally, perhaps an organ that we don't think about, that's the Bursa fabricius, where I swear this is not Gumboro. This is a bird which has been infected by HPAI. But as you can see, there is definitely some signs of bursitis, of edema of the mucosa of the bursa, with even some petechial hemorrhages here in the plicae of that bursa. So it's not always Gumboro disease, but it can also be some systemic infection disease like HPAI. So just to conclude on my talk, as you saw, we can observe plenty of different signs, plenty of different clinical symptoms, either macroscopically or at necropsy. However, it's very, very difficult to conclude definitely on HPAI without running a very careful differential diagnosis and without going for further investigation. Most of the time, we have to go for laboratory investigations to definitely conclude on HPAI. But at least I wanted here to give you a few examples on some other conditions and to hopefully give you a kind of toolbox on what to bear in mind of what is rather HPAI and what is rather other conditions. When you see this, remember beginning of my talk with the swelling of the comb, of the wattles, of the very strong congestion and hemorrhages. This is a picture of fall cholera, so of Pasteurella multocida. So this can also show some other systemic inflammation in the internal organs. So that's definitely one of the conditions that we'll have to bear in mind. Probably it's not inducing such a high and sudden mortality. Obviously, is going to be able to respond to antibiotic treatment. So you always have some clues on how to investigate further fall cholera or HPAI. That's obviously some hemorrhages in the mucosa of the proventriculus, but this is Newcastle disease. This is velogenic Newcastle disease. Remember, it could also be the result of mycotoxins. There are some other conditions, but at least these are, according to me, the two main ones besides HPAI where we have to bear in mind as a differential diagnosis. Probably when it's Newcastle disease, then you're gonna see these hemorrhages everywhere in this proventriculus or at the junction with the esophagus. Whereas with HPAI, you're going to see it more likely on the tip of the glands. However, honestly, in the field, it's very, very difficult to apply this type of rule of thumb to rule out either Newcastle or HPAI. that's a beginning of acute tracheitis, as you can see here, with some hemorrhages in the cartilage, in the mucosa, in the lumen of the trachea, as well as with some excess mucous material inside the lumen of the trachea. However, this is a sign of infectious bronchitis. But of course, in this case, you should not get such a high mortality rate and high morbidity rate if it's just infectious bronchitis. Of course, if there is some secondary opportunistic infection, that's a different scenario. But infectious bronchitis by itself will not induce, let's say, 100% morbidity and almost 80% mortality within a few days. That's another trachea, severely inflamed. In this case, because we have free blood in the lumen, it turns out to become fibrin, like this, what we call a cheesy material that can be easily brought out by some equipment. In this case, this is infectious laryngotracheitis. That's a very strong kidney infection, kidney swelling, inflammation, as you can see here, extremely edematous, as well as with very strong urate depositions. So obviously we have first to check the water quality whenever it is there is some excess of salt, or whether there has been some water deprivation. So you see more management issues. And then in terms of infections, we have to think about either infectious bronchitis, especially some nephropathogenic isolates, or infectious bursal disease that can also induce such type of signs. This picture in particular was taken after a variant 2 variant infectious bronchitis infection. Again, remember infection of the trachea, as well as some hemorrhages in the thigh muscles or breast muscles. This is very typical for Gumboro disease or infectious bursal disease, but unfortunately, from time to time, that's also what we can observe in case of infectious, highly pathogenic avian influenza. That's a very typical torticollis sign of Newcastle disease, but this can also be due, obviously, to some vitamin deficiency, as well as avian encephalomyelitis. So this has to be bear in mind. But again, with Newcastle disease, especially with the neurotropic isolates of Newcastle disease, you're going to have either this stargazing position of the bird, or some convulsions with some frequent movements of the birds. This is very much Newcastle disease. And again, for avian influenza, this is not so frequent to observe nervous disorders. These legs, these shanks, look very much what I presented you earlier. But that's not avian influenza. This is called Alabama red leg. What is it? That's signs of Marek's disease, because these are tumors in the foot and in the shanks. So this is something, again, to bear in mind in your differential diagnosis. Now, in terms of egg drops, there are plenty of conditions besides management, again, management first. But in terms of infections, there are many of conditions that may induce some egg drops. So I tried to put in a kind of toolbox, a table to help you identify, according to what you are observing, whenever it's rather this condition or this other condition. Namely, if you observe in drop in quantity, in quality of the shell, and or in the inner quality. If there is a yes in each and every of these items, then it's rather infectious bronchitis. In other words, infectious bronchitis virus is able to induce a drop in quality of eggs, a drop in outside shell quality, as well as inside quality. You know that the albumen is very watery. There is a very drop in the hog units. It's not viscous as it should be. If it's Newcastle or HPAI, you don't have such a drop in inside egg quality. You only have a drop in outside quality, so the shell quality as well as the quantity. And whenever it's laryngotracheitis or marek or Mycoplasma gallisepticum, then you should rather have a drop in quantity, but not that much in the shell quality, neither in the inside quality. So as you can see with this very simplistic table, I tried to give you some clues in terms of differential diagnosis of egg drop. Probably the most difficult one is to differentiate HPAI from Pathogenic Newcastle. So I tried to put it again in a table to show you some signs like these ones, nervous signs that should rather suggest you Newcastle disease. Again, they are not absent in HPAI, but they are not so frequent. So torticollis, ataxia, because there is some encephalitis, inflammation in the Peyer patches, in the cecal tonsils, as well as some pseudomembranes, necrotic pseudomembranes inside the gut mucosa. This should rather be a sign of Newcastle instead of a sign of influenza. Vice versa, if you observe these subcutaneous hemorrhages in the camp, in the wattles, in the shanks, as well as this hemorrhagic in the pancreas, this should rather suggest you avian influenza, besides this sign of acute morbidity and mortality. So you see, I'm trying here to give you some ideas on differential diagnosis. Finally, I would like to share with you the early warning system that is in force in my country, in France. Obviously, it's totally different from Saudi Arabia because we are ND-free, we are Pathogenic ND-free, and we are also highly pathogenic avian influenza free. So this may not apply 100% to the Saudi situation, but at least this is to give you some ideas and perhaps to have some discussion about that. So this decree, or let's say this law, states the following, and there are some forms that are put on the walls in the farms just for the farmer to keep these early warnings in mind. So whenever you observe an increased mortality by 4% for just one day, or when it's twice higher within 2 days, starting from a threshold of more than 0.5%, or if you observe a drop in water intake for more than 50% for one day, or more than 25% per day for 3 consecutive days. This should be an early warning sign of HPAI. And the same applies for water intake. Finally, if there is a drop in egg production of more than 15% for a day, or more than 5% per day for 3 consecutive days. And overall, if there is some prostration, then it's stated that the farmer must inform his veterinarian as soon as any of these above criteria is observed. So that's very clear. And then there is some further investigation which is going on. But again, this is the French legislation, the French scenario. This was just to share with you what is in force in my country. So that's the end of my talk. I'd like to thank you very much for your kind attention. These are not pictures from Saudi Arabia, but from Egypt, from let's say open markets. And again, I thank you very much for your kind attention. Shukran.
Thank you, Christophe, for your presentation. I'm sorry اعتذر لحضراتكم مش هنقدر نترجمة كاملة للمحاضرة بتاعت كريستوف لأن الوقت عشان نقدر نحافظ على الملتزمين بالوقت. هو قال لنا نقطتين مهمين في بداية المحاضرة، كنا بنتكلم على الفيروس نفسه. في نوعين من الانتيجينات على سطح الفيروس اللي هم جلوتين ومانيديز، يهمني فيهم جدا اللي هم جلوتينين لأن ده مسؤول عن التحام الخلية بالفيروس، وده اللي بيبقى بيتحدد على أساسه نوعين مهمين جدا اللي هم ال H5 وال H7 دول اللي بيبقى عليها تبليغ إلزامي منظمة صحة الحيوان إن هم دول شديدي الضراوة. وطرق الانتشار عديدة ودي هتتذكر في المحاضرة الأخرانية. كمان قلنا إن طبقا للوجود التتابع الجيني ممكن يبقى الفيروس حادي أو متعدد، فبيبقى يا إما يبقى منخفض الضراوة يتكاثر بس في الجهاز الهضمي والجهاز التنفسي، أو يبقى شديد الضراوة بيتكاثر في كل أجزاء جسم الطائر. طبعا هو عدد معانا المحاضرة كاملة أعراض كتيرة أنا مش هقدر أذكرها للأسف عشان ضيق الوقت عشان نبقى ملتزمين بالجدول بتاعنا. لو معانا وقت في نهاية المحاضرة هقوم بتلخيص كامل لبقية المحاضرة. So we will start with our second presenter, and she is Gwenelle Defont. She is a veterinarian graduated from France and earned a master in microbiology and ecology and a PhD in virology from a French university. For 10 years, she successfully worked as a researcher in the 2 national reference laboratories, one involved in safety and bacteriology of seafood products, and the other in animal virology, both parts of the Food Safety and Animal Health Public Agency under the French Ministry of Agriculture. Then she worked for 10 years in the Animal Health Service of the FAO, the Food Agriculture Organization of the United Nations, in the headquarters, and she was her focal point for the FAO as a coordinator for the laboratory unit in charge of FAO global projects on the veterinary laboratory strengthening and diagnosis in developing countries. She moved to Seva Santé Animale in 2017, where she is now the coordinator of the scientific activities in the Scientific and Innovation Direction, which conducts research and animal vaccine prototype and registered vaccine. She is based in France and at Seva headquarters and remains very much involved in avian influenza activities. So, Gwenelle, the stage is yours, and please try to stick to the time.
Okay, so salam alaikum. Good morning, everyone. I'm very pleased to be able to give you this presentation this morning, and I will focus my talk on HPI virus evolution, epidemiological distribution, and OIE regulations. Sorry, the slides are not moving. Okay. So I will focus this part on HPI virus evolution on H5 only, because there's so much to be said already just on H5. Christophe already showed you this diagram, which shows a virus particle for influenza. And this virus particle is actually made of 8 RNA segments. And each of these RNA segments codes for at least 1 protein. We have 6 internal and structural proteins and 2 external proteins, which are called hemagglutinin, HA, and neuraminidase, NA. So these 2 external proteins are used for the classification of influenza subtype. And so we have 18 types and H types and 11 N types. So these types are actually distributed among different species, and wild birds are actually the natural reservoir of influenza viruses, especially white ducks. So you can find all these subtypes in white ducks, while you find only some of these subtypes in other animals, domestic or wild animals. For example, horses can only be infected with H3 or H7 viruses. Avian or poultry are mostly infected with H5, H7, and H9. And we shouldn't forget about these birds, bustards and falcons, which have a great epidemiological role to play in your country. So, and now I'm going to start in describing the evolution of this virus. So, influenza viruses are highly evolutive viruses, and this high level of evolution is based on two mechanisms. The first one is related to the fact that influenza viruses are RNA viruses, and the polymerase, which is the enzyme that replicates the RNA, has a lot of generates a lot of errors when it replicates the RNA, and this gives the virus an opportunity to actually mutate because of these errors in the sequence. And this is an example of the phylogenetic tree of an influenza H5 virus. And this is a typical phylogenetic tree of a virus that shows a high level of evolution. It has a lot of different clusters with a node and a new cluster, another one here, another one here. And within each cluster, you can also see a high level of evolution because the virus continues to evolve and to go on the right hand side of the tree. And there is a second mechanism of virus evolution, which is based on the fact that influenza viruses are RNA segmented viruses, and these segments almost work independently, and they can be reassorted. So, for example, if you have, let's say, a red virus, a given virus, and a gray virus that both infect a cell, they will both replicate their RNA in the cell, and then the infectious particle will be formed. And actually, the viruses that will come out of this infected cell can well be a chimeric virus that will be made of RNA segments from the two originating viruses. And this reassortment is able for the virus to make big steps in its evolution. And this is called antigenic shift, while the mutations that I have described earlier is called antigenic drift. So it's a step-by-step with little steps of evolution. And the influenza viruses are able to evolve on these both mechanisms. So regarding the antigenic shift, the reassortment of segments, actually H9N2 is a very central subtype in this evolutionary mode, because it has been shown that this virus has actually acted as a gene donor to other viruses, especially a gene donor for all these H5 viruses that I'm going to talk about today, and also a gene donor to the H7N9 virus, which emerged in China in 2013, and which has also had huge impacts on the Chinese poultry industry. It has also donated internal genes in China to several other subtypes. So what does the H5N1 make it a very unique virus with a very unique history? There are several reasons for that. First, the H5N1 has been able to spread in many, many countries, more than 70 countries. It's been around for 15 years, and it's been spread across continents, and it has been able to evolve a lot, and this is what I'm going to describe. So this is a very unique virus. And in the past and in the future also, we've seen the emergence of highly pathogenic avian influenza viruses in many countries, which usually started by being a low path, which reverted to high path. But these were usually located in a given country and they were finally controlled. But this one is a virus which is very difficult to control. It's able to spread a lot. So the whole story of H5N1 started with this given strain, which was actually isolated in a goose in the Guangdong province of China. And so all the H5 HPI viruses that we're going to talk about are actually derived from this historical strain that is, and this is the way in which it is usually described. This is the goose Guangdong H5 lineage. And this virus started to circulate within China. They had also some cases in Hong Kong. And later on, from 2004, it started spreading across the world. And in 2008, WHO, OIE, and FAO were actually tasked to develop a nomenclature because the virus was spreading so much, and the fact that it was spreading so much and infecting so many species and so many birds that it gave the virus opportunities to evolve. So the nomenclature group worked on a way to be able to differentiate these viruses. So they worked on the H5, the hemagglutinin gene, and this is the nomenclature that they determined. So first they defined some criteria, and the criteria was that when a group evolves so much and mutations are so high that the sequence divergence between viruses within a group is above 1.5%, then we would create a new cluster that we call a clade. So they gathered in about 2005 initially. So they looked at historical viruses, and this is the diagram that they created. So when this goose Guangdong virus emerged, first it had only 4 clades, and then for the first 5 years. Then the next 5 years, new clades emerged. So they had 10 clades at that time, from clade 0 to clade 9. And then afterwards, some of these clades disappeared little by little, but others managed to expand a bit more. So in that time, around 2005, the clade that really expanded a lot was the clade 2. And this clade 2 managed to spread outside of Asia to other countries. And it evolved so much that they had to create a second order clade, and they subdivided the clade 2 into 2.2, 2.1, etc., up to 2.3. And afterwards, this clade 2 had also continued to evolve, especially the clade 2.3. So they had to create a third order clade for the 2.3 and for the 2.1 clade. So we had the 2.3.1, 2.3.2, etc. And the same with the 2.1, which was evolving in Indonesia. And afterwards, even a few years, only 2 years later, they had to add a fourth order clade, so another digit, because the clade 2.3.4 had even more circulated, replicated again in birds, and it had to be further divided. So this is a clade which expanded a lot in many countries, and this clade is the typical clade that has been circulating and evolving in Egypt, and this one, the clade that has been evolving in Indonesia, and this one in southern China and Vietnam. So these are the publications that were issued by this WHO OIE FAO working group. They first proposed a nomenclature in 2008, and then the next year they had to work on the clade 2.2 viruses in particular. Then in 2011, they proposed an evolutionary, an update of the nomenclature. And then sorry, it's blocked again. Okay, in 2014, they had to revise the nomenclature again. And the next year, they had to revise the nomenclature just for the creation of new subclade. So let me take the example of the last nomenclature, overall nomenclature that was issued in 2014. So this is an example of new clade designation. For example, the 1.1 was too much divergent within this group. So they decided to create the 1.1.1 and the 1.1.2. And this is the overall phylogenetic tree that they produced. So what we can see from this tree, first is that some clades have actually disappeared. These are the remaining circulating clades in 2014. For example, we cannot see the clade 0 or the clade 9 or the clade 3. These ones have disappeared. They have been dominated by other clades, especially the clade 2. What we can also see is a high level of diversity. We have big groups which are well defined in the phylogenetic tree, and within each group you can see that there's still a continuing evolution because the branches of a tree are very long actually. And last thing you can see is the goose guangdong 96 virus, which is here, which is the common ancestor, which is the root of a tree. And all these viruses actually are derived from this common ancestor. So in addition to this genetic drift that I have just described, the virus also continued to reassort. And actually the clade 2.3.4.4 seems to have reassorted even more as compared to other clades. And this is a figure from a very nice Chinese paper, which managed to look at sequence information, reassortments, and which managed to describe the reassortments that we think probably happened. So actually it was a clade 2.3.4 virus, which probably reassorted. So that was a virus from poultry, which probably reassorted with a duck virus, which was an H5N5. And this gave H5N8 and H5N2 viruses, which today can infect many species, including wild birds and ducks and poultry. And you can see from this complex figure that then these viruses, H5N2 and H5N8, also reassorted again with other viruses, and this gave actually H5N6 viruses. So today we can see not only the circulation of different clades, but also the circulation of different subtypes, namely H5N1, H5N2, and N5, N6, and N8. So it is actually more right to say HPI, H5NX today. So WHO has been actually monitoring the evolution of human seasonal vaccines for more than 50 years. And since this H5 virus started to circulate worldwide and to infect humans, WHO also started to also monitor the evolution of H5 viruses. So for the selection of human vaccine strain, they meet twice a year, where they look at the antigenic and genetic and epidemiological data. They look at the virus evolution and spread, geographic spread, and they decide what vaccine candidate vaccine viruses to select. So 15 years ago, they decided to start also monitoring H5 viruses because of the risk to humans. And this is the list of all H5 viruses that have been so far selected by WHO. And so these viruses have been selected, requested to the countries, and candidate vaccine viruses have been generated. And these viruses are antigens are strains which are ready to go for vaccine manufacturing in case there was a start of a pandemic or at least a huge epizootic. And you can see the most recent strains here that are under preparation. And those recent strains are 2.3.2.1 strains from Bangladesh, Ghana, from China, and also some 2.3.4.4 strains. So these have been the most circulating strains in the last period. So now, if we want to link this virus evolution with geographical evolution, I am going to show you a very nice visualization tool that is public, and it is called NextStrain. And if you actually look at the overall phylogenetic evolution of H5 linked with the geographical distribution, you can even play it, and you can see the virus that occurred first in Asia. And if I stop this video just here, before 2004, the virus was only evolving and circulating mostly in China, and started infecting neighboring countries, here Indonesia from 2003. And then the first wave of migration through migratory birds occurred through to Europe and Middle East and Africa. And we have different colors because once a virus hit a territory, then it locally evolved. So you can see here 15 years of virus circulation and evolution. And then if you look at the tree itself, if you just go on the different...
sorry, Gwanel, for interruption, but your screen is not showing anything.
Can you please repeat, Hazem?
Your screen is not showing anything.
Ah, okay, my screen is not showing anything.
Yeah.
Okay.
Yeah. Okay.
So let me go back then to my presentation. Can you see my presentation?
Yes, now we can see.
Okay. Sorry. So I was showing actually a dynamic map. So I was showing that from until 2004, when you look at all these viruses, they were all blue. So they were only circulating in Asia. And then from 2004, you can see that these yellow brownish viruses invaded Europe and the Middle East and Africa, and then they evolved locally. So, for example, these were European viruses here, and this very long branch here is our only Egyptian viruses. So once the 2.2 clade viruses hit Egypt, they locally evolved, and they remain very local. And it is exactly the same with Indonesia. All this branch here are Indonesian viruses. Indonesia was first affected in 2003, and since then they were affected by the clade 2.1, and since then the virus locally evolved there. So just to finish on the evolution of HPI viruses, why is it important to monitor virus evolution? First, to make sure that the diagnostic tools that we have, especially PCR, which is a very quick, very sensitive test, but also a highly specific test, we have to make sure that PCR is constantly able to detect the circulating strains, including the new circulating strains, because the virus can mutate, and then the PCR can lose sensitivity. Then it is also important to have to monitor viruses and make sure you have a good matching between your vaccine strain and your circulating viruses. This is especially true for inactivated vaccines. Then it is also important to know what clade is circulating in your country, to be able to trace infection, to see if your clade was coming from migratory birds or rather from other sources, for example. And lastly, also because the different clades that I have described actually have different features. Some clades are, for example, more pathogenic in chickens. Others are more pathogenic in ducks or ducklings. Others are more able to be transported by migratory birds. And this was actually the case of clades 2.2 and then further clades 2.2.3.1 or 2.2.4.4, which were more transported by migratory birds. And also some clades have more ability to infect mammals, especially humans. Humans have not been infected by every clades, just some specific clades. So now let's move to the epidemiological distribution. I requested FAO to actually prepare this map for our meeting. And this is a map that covers 5 years of H5 and H7 circulation. So what you can see from this map first is that H5 viruses have been able to infect many continents. And we can't see H5 here in the US because they were infected just the year before, but the year before this would have been full of dots as well. So the only continents that have not been infected so far by HPI in the last years and by H5 are Australia and South America. What you can also see here is that some countries have a lot of dots, especially China, which is actually the capital of avian influenza. It has all the subtypes that we can imagine. And we can also see a high diversity with the different colors. So different clades and subtypes are actually circulating. And within this 5 years period, we see a lot of pink. And the pink are actually the H5 and 8 clade 2.3.4.4 viruses. I need to mention that the virus has become enzootic in a few countries, and namely Bangladesh, China, Egypt, Indonesia, Nepal, Nigeria, and Vietnam, which means that these countries, the first year where they got infected, the virus managed to get persistent in their poultry industry, and they never managed to get rid of, to fully control the virus. All these countries have a very big poultry industry, and they also have live bird markets. They have a lot of backyard poultry. So it is very difficult to get rid of the virus. And they also got several introductions. So they didn't, even Indonesia, they didn't even stick to just one subtype or one clade, but they were infected with several subtypes, especially Nigeria and Egypt and China. Then we have other dots, a lot of dots in these countries, and these countries have actually managed so far to remain epizootic in that they've been able to control the disease and avoid it to become persistent. And this implies a lot of efforts to rapidly detect the disease and rapidly intervene and do the massive culling that is required. So this is very important. Then we also have the map that only covers the last year. And you can see from this map that the level of outbreaks is far lower. So it has been a more quiet period. But in your country, you had to face an outbreak in February this year. And you can see that we have 3 main virus strains that have been circulating, H5 and 8 in several countries, and still in Asia, H5N1 and H5 and 6. So this map to show that almost the same scenario happened in 4 different intercontinental waves. We had these 4 waves overlapping between 2 years. It happened during wintertime. So and each time we had a spring migration, like every year, in April of ducks in Korea and northern China. And with these waves, these ducks actually carried a new strain, from the previous year, a HPI strain, then these white ducks would gather in Mongolia and northern China and southern Russia in May, June. And then afterwards, with more migrations with other ducks, in October, so at the beginning of winter, we would see the same strain that was isolated here, the same strain being transported and then scattered to both European countries and Middle Eastern and African countries. So this scenario happened already 4 times, and the biggest wave was, at least for Europe, was in 2016 and 17, with many outbreaks, especially H5N8 outbreaks. So now let's move to OIE regulations on HPI. If you want to have details about the OIE regulations, you can visit the OIE website, and you can find in the OIE code the special chapter, the 10.4 chapter on infection with avian influenza viruses. So I'm just going to give you some key elements of this chapter. First, the notification of avian influenza outbreaks. OIE differentiates the notifiable influenza viruses from the non-notifiable ones. And the notifiable viruses outbreaks are outbreaks that occur in poultry and wild birds, which are due to highly pathogenic avian influenza. How do we know it is highly pathogenic? Usually it's more than 70% mortality, but as Christophe showed in the previous presentation, it is even finer to define that it is a highly pathogenic avian influenza. Then in poultry only, any influenza virus that is an H5 or H7 is considered, has to be notified to be OIE, because if it is low path, it has a high chance of reverting to becoming a high path virus. This is why it should be notified even if it's still a low path. And so the non-notifiable viruses to be OIE are those outbreaks that are due to low pathogenic avian influenza and those that are not H5 or H7. This is a typical example of low path AI due to H9 and 2. And this classification actually has big implications in terms of disease prevention and control. So OIE is also very prescriptive in the avian surveillance program. And this is what they describe in their article number 28. First, they state that it should be a continuing program. It shouldn't be stopped. It should be based on an early warning. And this early warning system is actually based on a nice public-private partnership, in that the farmers, workers, and diagnosticians should report promptly any suspicion of avian influenza to the veterinary authority. All suspected cases should be immediately investigated. Samples should be taken and submitted to a lab for appropriate tests. Personnel responsible for surveillance should be able to call for assistance from a team with expertise in avian influenza diagnosis and control. And in case there's any potential public health implication, for example, if we know that a clade which is present has already infected human beings, then it should be notified to the appropriate public health authorities. And lastly, OIE also prescribes, when relevant, regular and frequent clinical inspection and serological and virological testing of high-risk group of animals. For example, if your neighboring country is infected with AI, you will focus your surveillance on the border with this country. Or if you have live bird markets with a mix of different birds of different species and origins, you would perform surveillance in live bird markets. Or if you have migratory birds in your country which are close to poultry farms, then that's where you would focus your surveillance. Then OIE, for notifiable avian influenzas, OIE prescribes the stamping out policy, which is more described in another chapter, the chapter 7.6. And this stamping out policy describes the killing of animals, which are the affected animals as well as the suspected ones, and the ones that have an epidemiological link with the affected or suspected animals. It also describes the disposal of carcasses and the cleansing and disinfection of establishments. Then OIE also describes when a country can recover the free status. So if a country has reported HPI in the country or in a zone or compartment, they can only regain the free status after 3 months, 3 months after the stamping out policy, which also includes disinfection of all establishments. And it is provided if the country has shown that they have conducted surveillance during these 3 months, and that surveillance has shown that the virus is not active anymore in the country. Then OIE has a lot of different articles on the trade, because avian influenza is a big barrier to poultry trade. So they describe the trade of different poultry products. I will just take the example of the trade of fresh meat of poultry. So first of all, only countries that are countries or zones of compartments that are free of avian influenza, notifiable avian influenza, can trade. They can trade their poultry. And if a country wants to import poultry from another country, they would request an international veterinary certificate, and this certificate should attest that the entire consignment of meat comes from a free zone, which was free when the poultry was hatched, and or for at least the past 21 days. And they also have to show that the poultry was slaughtered in an approved abattoir, and that the poultry had been subjected to ante and post-mortem inspection. And the last article that I would like to highlight is the one on vaccination. And or actually, OIE does not allows vaccination and allows trading of poultry even in countries that apply vaccination. So if a country applies vaccination, they would have to specify the vaccine that was used and vaccination program in the international veterinary certificate. So just 2 more slides on OIE approaches. One is for those who are not familiar with the approach for OIE in terms of zoning and compartmentalization. First, if a country has a circulating avian influenza and they want to isolate a zone or a region based on administrative boundaries like a province, or based on geographical boundaries, for example, between 2 mountains or 2 rivers, then a country can define this zone and conduct a specific surveillance, and they can apply to the OIE and request the status of the zone to be a free zone. Then it would allow them to continue trading with other countries. Similarly, they can also define a compartment. For example, the poultry integrator can also request to be acknowledged as a free zone, and so it means that they would have to show good biosecurity, surveillance, all the guarantees that they are free, even if the rest of the country may be infected with avian influenza. And lastly, OIE very much promotes the public-private partnership, and so does FAO as well. And this is actually actually vital for a country to be able to monitor disease presence and to be able to intervene quickly and efficiently. So now it's time for conclusion. First, avian influenza viruses still dramatically affect the poultry industry globally. and is still a big barrier to poultry trade. Goose Guangdong H5 HPI viruses are very unique viruses. They've been circulating for over 15 years. They have become enzootic in several countries. They have infected wild birds. They have been transported by wild birds, and they continue to cause many outbreaks in domestic poultry and also sporadic human infections. HPI infections and outbreaks are highly regulated across the world. The prevention and control of HPI infections requires a combination of disease control and prevention measures, and these need to be coordinated between public and private sectors. So it is both the responsibility of private and public veterinarians to protect animals and humans. And lastly, the key for the control of HPI is really to rely on a very quick detection, quick reporting, and early intervention. Thank you, everyone. And I'm finished with my presentation.
Thank you, Gwana. Thank you, Gwana. بعتذر من حضراتكم برضو، احنا عشان نضيف الوقت مش هنقدر نقوم بعملية الترجمة. هندخل في المحاضرة اللي وراها، واحنا عملنا عملية بس تبديل محاضرة الدكتور سند، فهنستأذن الدكتور سند ان هو يبتدي يشير بتاعته.
شكرا اخوي حازم، والشكر موصول للزملاء. انا عارف ان تجاوزنا الوقت بكثير، فنبي نحاول نبدا بشكل سريع استعراض خطه الطوارئ لانفلونزا الطيور المتبعه في المملكه. وفي البدايه دعونا نشكر الدكتور على التنظيم وحازم لحسن إدارة الوقت. في البداية نبدأ في الماب لخطة الطوارئ في المملكة العربية السعودية. حقيقة تم إعداد هذه الخطة من الاندلاع السابقة، وتم تحديثها في لعام 2007، وتم تحديثها في الاندلاع عام 2017. تم معالجة العديد من الملاحظات التي كانت لوحظت في بعد انتهاء أزمة 2017 الخاصة بمرض انفلونزا الطيور عالي الضراوة. يبدأ المسار من وجود اشتباه سواء عند مواطن أو مشروع دواجن، فيتم مباشرة إبلاغ غرفة الطوارئ في الوزارة لاستقبال البلاغ. بعد كده يتم تكليف ضباط اتصال أو فرق الطوارئ الميدانية لمباشرة الموقع. في حال الاشتباه يتم تطبيق إجراءات معينة. في حال الاشتباه بمرض آخر غير انفلونزا الطيور يتم إغلاق البلاغ. في الحالة الأولى يتم حظر الموقع وسحب عينات محددة وخطة الطوارئ. بعد ظهور النتائج يتم اتجاه نحو مسارين. المسار في حال كانت النتيجة سلبية يتم إغلاق البلاغ. في حال كانت إيجابية يتم إرسال فرق الطوارئ للموقع لتطبيق الإجراءات المنصوص عليها في خطة الطوارئ. في خطة الطوارئ قسمنا المناطق من بؤرة الإصابة إلى 3 مناطق. المنطقة الأولى اللي هي منطقة الإصابة، والمنطقة الثانية اللي هي المنطقة المحظورة، والمنطقة الأخيرة هي منطقة المراقبة بالنسبة لبؤرة الإصابة. في عملية إدارة البلاغات عادة ما يتم استلام البلاغات من الغرفة المركزية لمعلومة الطوارئ. طبعا احنا وضعنا البرزنتيشن في جزئيات في اللغة الإنجليزية للإخوان المشاركين معنا. في المرحلة الثانية يتم تطبيق كافة الإجراءات والوقائية والسلامة المهنية لمنع انتقال العدوى خارج الموقع. أيضا يتم حجر على الموقع وأخذ تعهد على صاحب الموقع أو المشروع بعدم إدخال أو نقل الطيور من موقع حتى ظهور نتائج الفحص المخبري. أيضا يتم التخلص من الطيور النافقة بالطرق الصحية المعتمدة وفق الخطة. أيضا يتم تطهير المعدات في الموقع القابل للتطهير والمنصوص عليها في خطة الطوارئ. إجراءات البلاغ من يبدأ من استلامه لحتى مباشرة الفرق الميدانية للموقع خلال مدة لا تتجاوز ساعتين. في المرة الثانية يتم إرسال العينات خلال 24 ساعة. بهذا يعني أن العينات وصلت للمختبر خلال 24 ساعة من استلام البلاغ في حال خروج الفرق الطوارئ والتأكد من وجود الاشتباه. طبعا العينات في خطة الطوارئ لدينا 4 أنواع من العينات: مسحات من القصبة الهوائية، ومسحات من فتحة المجمع، وأحشاء داخلية، وطيور نافقة حديثة. بعد ظهور النتائج الإيجابية يجب أن يتم تشكيل لجنة تعويضات وفق نظام الثروة الحيوانية في المملكة، وهذه اللجنة لابد أن تتكون من عضو من وزارة البيئة والمياه والزراعة، وعضو من وزارة الداخلية والإمارة، وعضو من وزارة البلدية والشؤون القروية، وعضو من وزارة المالية. طبعا لدينا إجراءات يتم تنفيذها في بؤرة الإصابة، تبدأ بالتخلص الآمن من جميع أنواع الطيور الحية المتواجدة في بؤرة الإصابة كاملة، ومنتجاتها أيضا، وبيض التفقيس ومخلفاتها والأعلاف والأدوات المستخدمة في رعايتها الغير قابلة للتطهير. أيضا يتم تطهير المباني والمعدات والمركبات في المشروع وفق اشتراطات الأمن الحيوي التي تقرها الوزارة. أيضا يحظر خروج المركبات والمعدات من المشروع المصاب. أيضا يتم أخذ تعهد على صاحب المشروع أو الموقع بعدم التصرف أو نقل أو في الموجودات من والموظفين العاملين في المشروع. أيضا يتم حصر وتتبع الطيور أو الأعلاف أو السيارات التي تم خروجها قبل 21 يوم من بؤرة الإصابة. أيضا يتم التخلص، أيضا يتم متابعة النافق اليومي للمشاريع الواقعة داخل المنطقة الأولى التي تم الإشارة إليها في بداية العرض. أيضا يحظر مرور السيارات المحملة بالطيور وبيض التنقيص وبيض الصيصان والأعلاف عبر المنطقة المصابة، ولا يسمح للمشاريع أيضا بالتسكين في هذه المنطقة. أيضا يمنع خروج المركبات الأعلاف من مصانع الأعلاف والسيلوهات في المناطق المصابة لحين رفع الحظر عنها. كما يتم تنفيذ استقصاء وبائي شامل للمشاريع الموجودة في المنطقة في الثلاث دوائر الثانية: المراقبة والمحظورة. أيضا يجب إلزام العاملين باتخاذ الإجراءات اللازمة لمنع انتقال العدوى من موقع الإصابة عند الخروج من المشروع. المنطقة المحظورة يتم إبلاغ المشاريع بإلزامية تطبيقها على معايير الأمن الحيوي وتعزيز إجراءات الرقابة البيطرية. أيضا متابعة النافق اليومي في هذه المشاريع وإرسالها بشكل يومي إلى غرفة الطوارئ. أيضا يتم إغلاق الأسواق وتجمعات الطيور التي تقع داخل المنطقة المحظورة. أيضا يتم إجراء عمل تقصي ومراقبة للمشاريع والتربية الريفية الموجودة في المنطقة. أيضا يتم إيقاف سيارات الأعلاف من الخروج من هذه المنطقة إلا بعد تطهيرها. أيضا يتم تطبيق الحظر الجزئي على حركة الطيور من وإلى المنطقة المحظورة، ويتم تطبيقها كالتالي بعد الحصول على إذن خطي من الوزارة. ويسمح بخروج الطيور في عمر الذبح إلى المسالخ بغرض الذبح الفوري. أيضا خروج الصيصان أمر يوم واحد، خروج بيض المائدة والتفقيس، وخروج الأعلاف من مصانع الأعلاف، وخروج المعدات بعد تطهيرها. ويجب أن يتم تطهير المركبات في كل التي يتم السماح بخروجها. أيضا لا يسمح بإعادة التسكين في المشاريع إلا بعد رفع الحظر عن المنطقة. أيضا يتم السماح بمرور السيارات المحملة في المنطقة المحظورة المحملة في بيض التفقيس والصيصان. أيضا يتم رفع الحظر عن المنطقة، رفع الحظر عن المنطقة المصابة. في منطقة المراقبة هي الدائرة الثالثة، واللي هي تبعد تقريبا 10 كيلومتر من بؤرة الإصابة. يتم تطبيق أيضا إجراءات وقائية صارمة على المشاريع في المنطقة، غلق الأسواق الطيور الحية وتجمعات الطيور التي تقع داخل حدود منطقة المراقبة، أيضا إيقاف خروج السيارات والأعلاف من المواقع، أيضا حظر خروج الطيور من المنطقة إلا بتصريح. أيضا يتم عدم السماح بتسكين طيور من مشاريع أخرى عدا مشاريع الدجاج اللاحم، فهو يسمح في تسكينها داخل هذه المنطقة. أيضا يسمح بذبح الطيور داخل مسالخ في منطقة المراقبة من جميع مناطق المملكة ما عدا من جميع المناطق عدا منطقتين، الأولى اللي هي الإصابة والمنطقة الثانية اللي هي منطقة المحظور. يسمح بخروج المخلفات والفرشة والمعدات بعد تطهيرها، يسمح بمرور السيارات، ويتم رفع الحظر عن هذه المنطقة بعد رفع الحظر عن المنطقة الأولى اللي هي منطقة الإصابة. رفع الحظر يتم بعد تأكد من خلو المنطقة بوضع طيور كاشفة. وفي الإصابات الريفية بعد 30 يوم من تطهير بؤرة الإصابة يتم رفع الطلب للوزارة من قبل فرع الوزارة بهدف بطلب رفع الحظر عن المنطقة بعد مرور 30 يوم من ظهور نتائج الطيور الكاشفة. للطيور داخل المنازل بعد 21 يوم من تطهير الموقع، ولا يشترط وضع طيور كاشفة في هذه الحالة. بالنسبة لأسواق الطيور والمحلات أيضا يجب انقضاء 30 يوم لمشاريع الدواجن و30 يوم لمحلات الطيور في الأسواق من تاريخ الانتهاء من آخر عملية التطهير بعد ظهور نتائج الطيور الكاشفة السلبية. أيضا يجب أن لا يكون المشروع والسوق واقع ضمن بؤرة إصابة أخرى، ويجب أن تكون جميع نتائج المسوحات الوبائية سلبية. هذا بشكل مختصر خطة الطوارئ لمرض انفلونزا الطيور عالي الضراوة. شكرا من أخوي حمزة، أنقل لك الكلمة.
مشكور دكتور سند. So we will continue with our last presenter, Dr. Jaime. He has been graduated in 2004 from Madrid, Spain, and he has a PhD diploma in the facility in the poultry pathology. His career experience, he's granted scholarship in the Department of Poultry Pathology, University of Madrid, from the period 2006-2007. Then after that, he started work as a specialist in CAP Veterans Spain. His main duties were manager for CAP GP, stock and veterinary services, hatchery, breeder and broiler in Iberia and Europe, manager customer internal and external trials, hatchery, breeder and broilers, and manager for the scientific and data analysis application. In Paris, he became a lecturer in master degree in animal production and health, member of the executive committee of the WPSA Spanish branch. So please, Jaime, could you share your screen and be on stage?
Yes.
And
thank you.
More importantly, to finish within 30 minutes.
I know. So
thank you.
Just a second. Don't worry that I will be on time. Let me check with you my presentation. Just a second. I don't know. Okay. Can you see my screen? It's okay? Okay. So first of all, I would like to thank you all for inviting me and us, our company, to be here with us. And really, I would like to thank you, the Ministry of Environment, Water and Agriculture, because for us it's a real pleasure to be able to share a little bit of information with all of you. Well, in this case, I'm going to talk about biosecurity in poultry farms, some field experience that I hope that they will help you. It's just my experience during all this year, but I hope that you will see something that can be helpful for all of you. So, well, these are the programs that we are going to develop in this presentation. The first program is that we are going to have a short introduction. Then we are going to talk about some biosecurity practices in poultry farm, and finally, a conclusion. Okay. So, just about biosecurity, one thing, just to say that is. Let me check it with this. Is that biosecurity is a set of good practices designed to prevent the entry and spread of disease on farms. It's a requirement of the markets. Maybe we want to export to a third country, and we are going to be audited by a third country to see if we are meeting all these requirements. This really could be a paranoid process that affects the responsible veterinarian. This could be an endless process. I mean, we can always add more things, add more steps, and we can never end. But we have to have common sense and to understand what we have to do. It has to be seen like an investment, not as an spend, and we have to understand that if one of us fails, we all fail. That's one of the most important messages I would like to send. Let me see. Okay, so first of all, now about the practices, we are going to talk about the location of the farm. The first thing that we have to say is that we have to avoid the high poultry density and risky zones. We have to follow the legislation. For example, here, if we are in a very high density area, one farm is going to be able to contaminate 2 or 3 or 4 or more farms. I mean, it's very risky. But if we are in a very low density area, one farm is going to be able to contaminate less than another farm. So how we placed is really important, because each farm has their own load of pathogens in its farm. So if we are very far, if the farms are very far one from other, this pathogenic load is going to reach the other farm in a very low quantity. But on the other hand, if we are very close, we have many farms in the same region, this bacterial viral load is going to be shared. And we are going to have a lot of outbreaks and problems. But this is not just a problem of outbreaks. It's also a problem of productivity. When we see, if we have farms places in a very high density area, normally the productivity of this farm is lower because all these farms are sharing between them, let's say like this pathogen load. For example, in this picture, let's say that it's very difficult to control an outbreak. We have in a few meters, we have a breeder house, a layer house, and a cattle house. In this case, it's not possible to have, or at least very difficult to keep these farms away from any problem. And also in the same case, this is a broiler farm. This is a very immense complex. And you see how, if we have an outbreak here, how difficult it's going to be to control this outbreak, because the pathogen load of each farm is going to be really shared with all the houses that are very close to them. So they are going to share all this pathogen load very easily. Also, fortunately, we have some platform that allows us to see where do we have placed our farm. So an important thing is that we have to have for our company maps like this. I mean, to see where we place it, where is our farm, hatchery, where are they placed? Because, for example, in this picture, we can see that we are surrounded by agricultural lands. Okay, so this could be okay, but we have to check if the farmers are using animal biosolids, are applying animal biosolids without or with treatment, because this could be a source of infection of MG, MS, and Salmonella also. Also, when they are, if we are surrounded by agricultural lands, when the farmers are moving the land, this can attract many birds. And in this case, for example, you can see the stokes. This was the source of an outbreak that was caused in Spain, let's say many years ago. But each time that they were moving the land, a lot of stokes came close to the farm and to pick the worms that were on it. Also, another good option is to do these wind maps. These wind maps can help us to be protected from the wind and from the dust. I mean, this kind of wind maps can be done by some professionals, and it's not difficult. Also, if we see that all this wind is coming towards our farms, we can plant here a few trees. A few trees they can help us to be prevented from the dust and wind. But if we have these trees very close to our farm, probably it's going to be almost worse, because all the vegetation is going to invade maybe our farm, and also many birds are going to be close to our farm. So there is always a minimum distance between our trees and the farms. Also, we have to avoid the high density roads. I mean, the ideal location for a poultry farm is a road with no way out, whose only destination is the farm. For example, this truck that is loaded with turkeys that is going to the slaughterhouse, it's emitting a lot of infectious particles that can affect our farm. So let's get away from these high density roads. Also, with this helicopter view, we can see if we are placed close to rivers or to lakes, where we can find some wild birds that can be reservoirs for avian influenza, for example. But it's not just only a problem that this kind of animals that are coming in the lakes can affect our farms. Is that if there are other farms close to this area, they can be infected too, and they can close our company to export to a third country. For example, even although we are not affected, but it's, as we have seen in the other talks, it could be a problem. So, for example, it's sometimes we have to do some zoning. This is kind of agreement there with different countries that maybe if we are far from the outbreak, we are able to keep exporting to a third country or to another region. But at least. But also, I would like to remark that it's something that sometimes depends on the countries, on the agreements that we have on the countries. And with the compartmentalization, more or less the same thing. This is compartmentalization is typical in the genetic companies that they consider, because they have and strict biosecurity measures, that each farm is an isolated unit. So if they have an outbreak close to them, maybe they can keep exporting to a third country. Also, always if there is an agreement between these countries. Okay. So, well, now let's talk about the surroundings and the control access. Okay, so this is a farm, an excellent farm, and we can see that one of the most important things is the external fencing, as you can see here. Then and any truck and no truck can need to get inside to unload the feed or to take the eggs out from the farm. We can see here that all the silos are placed outside the farm, so the truck doesn't need to get into the farm. And also the egg storage is more or less in the outside, so we don't need the truck to get into the farm to load the eggs. Also, if we have the external fences is really important, but if we have all the doors closed, it's like nothing. I mean, so we have to have all the time the doors closed, like things like this, like a padlock, but well closed. I mean, we don't have to leave all the time the doors open. And it is one of the home messages that I would like to send. It's very simple, but sometimes it's not achieved. Also, a current mistake is to have an incorrect angle of the slope of the drain. Okay, when it's raining, for example, we can have, if the angle is not correct, we can have a lot of water accumulate in the drain in here, and this can attract birds and mice and many other animals. So we have to be very careful and to measure if we have done it correctly. Okay. Also, if there is no way and we have to take all the trucks inside our farm, we have to disinfect this truck. So we have to check the foggers. If the disinfection foggers are working, because it's really common to see that the installation is perfect, but the foggers are blocked and they are not working. So we have to check them almost every day, and especially if the bottom foggers are working, we have to pay special attention, because in the bottom of the truck normally there is a lot of dirt there, but in the wheels that we pay a lot of attention when the truck is rolling in the road. The reach that the temperature that the wheels reach is very high. So it's also very important, but more important could be the bottom of the truck. So let's be careful with to disinfect correctly the bottom of the truck. Well, before entering, the first thing that we have to do is to complete the visitor's book, and to complete the last day that we visit a poultry farm. And also we have to know that to visit our farms, we have to go to the jungle, to older flocks. That is mandatory. And this is going to be really useful, because this is going to help us to conduct an epidemiological investigation in case we have any kind of problem. So we can write here all the names and the days, and this is going to help us in case we have a problem. But this is not the only way that we have to track the people that is getting in our farm. But we can also track the people that is outside our farm. This kind of technology is available already in some countries, and this awares the responsible of biosecurity who is around the farm. It's true that we need some cooperation. I mean, all the workers of the company needs to have installed the app, for example. But for example, if an employee is close to the farm, very close to the farm, the responsible of the biosecurity is going to be aware of it. Okay. Also, the sour. We think that souring is very easy, but it's not really. It's easy, but we have to pay attention also. We need some rules also to write down, like for example, 10 rules. For example, this picture, I like it a lot because this guy is taking a good sour. You see all the soap in his ear, in his nose, because sometimes we don't do this correctly. I mean, also we need a timer to be sure that we are taking a correct shower. And once we finish, we can use this mouthwash we can use this mouthwash also in the nose. With a cotton wool, we can use this mouthwash into our nose once we have taken the shower to be better disinfected. Okay. So, and how many showers do we need? Well, it depends on the company. It depends on the pressure that we have. But for example, in this case, we have a picture where we have the farms are here in blue, around blue, and here we have the first changing facilities. The people came here, change clothes, take the first shower, and from here they go to the farm and they take the second shower and the second change of clothes. So we can do this protocol 1, 2, or 3 times. So it depends. No, the maximum I've seen it's 3 times. Okay. So in some cases there are special measures for visitors. For example, you see the picture is not very good, but I think it's interesting. You see these red bars, and here there is a pool. So they force you to go under these red bars to be completely in contact with the chlorine bath, to not to escape. Let's say it like this. And in this case, for example, before you get into the farm with your normal casual clothes, they force you to go like this in zigzag to be completely disinfected. You can imagine then how was the clothes, the smell of the clothes, but it's like this, okay? Also about the clothing, we have farms with no professional clothing, farms with basic clothing, disposable clothes, and other farms that they have their own laundry system. So that's a very good system because the clothes, they don't get out of the farm. It's a closed cycle. So we have to, this is something that is also very, very useful. The boots is something really important also. I mean, we have to have outside boots and indoor boots, and we have to have different color for each one. I mean, because if the color is the same, at the end it's going to be a mess. So we have to have different colors for indoor and outdoor boots, and also to have a very good differentiation is very important between the dirty area and the clean area. Because if we don't do it like this, we are going to mix everything. For example, this space is not well limited, so we can step onto the indoor indoor with the outside boots. So we have to be very careful. So, but let's try to delimit it correctly. This, and also if we just have one boot, well, there are different types of boots. For example, we have boots that accumulate not a lot of dirt, and other boots that accumulate a lot of dirt. So there are different types of boots. And also, what is really important is to have in correct conditions the foot baths. I mean, a foot bath like this is useless, completely useless. We have to protect these foot baths from the sun also, and when we have a cover, could be much better. I mean, we need these foot baths if they are in the outside with a cover. Okay. Also, if we don't have foot baths, we can spray our boots with a disinfection solution each time that we get into the farm. That's another solution. And another solution could be use dry foot baths, that they are also common and they can work, I think, correctly. Well, now let's talk about controlling the inner vectors, the death vectors. Okay. The first thing is the material. I mean, we have to clean and disinfect all the material. And once we did it, we can keep all the material for 2 days in a quarantine room. This is really important also to keep, when we disinfected all the material, to keep it in a quarantine room for 2 days, for example, before getting all the material inside the house. But the best option is to have all the material program in advance in the farm. So we don't ask for new material. We need to have all the material already in our farms once we start the cycle with the birds. Also, the hatchery material is a really important material because this material normally is recycling between all the farms. For example, if we have a very clean farm, a very good disinfection process is okay. But if we are in this kind of farms and hatcheries that everything is very dirty, you can imagine that these dirty trays and dirty trolleys are going to come back to the farm, and we can contaminate and have a really an important outbreak. For example, we have here the breeder farm, hatchery, and broiler farms. One breeder farm is positive, then it's going to infect the hatchery. The hatchery is going to contaminate the broiler farm, and then probably it's going to come back if we don't wash properly our trolleys or trays. It's going to come back to the infection to the breeder farms. About the waters, well, we have to test the water line with a sponge. We introduce them and we take samples. Also, we have to clean the regulator. Sometimes we never do this. We leave it this for years. The pH must be under 7 and the chlorine between 3 and 5 ppm on the water line. Okay, and also pay attention. I would like you to pay attention a little bit to the cooling disinfection system. Sometimes this water is recycling all the time, and the water is really dirty. So we have to be careful with it, and we can apply some type of pills, chlorine pills, that it could be helpful, or any other disinfection method. But we have to be careful with this. Okay. About the feed, well, all know that we can use heat and chemical treatment to prevent salmonella, but follow local legislation on type of treatment allowed, okay? Normally, the pellets, they already suffer a heat treatment, and normally they are safer than the mash feed. But right now there are some heat treatment for the mash feed also. So, well, we have to choose. About the live vectors, let's start with the Alphitobius, with the dark beetle, okay? The reproduction of this beetle, as we all know, is incredibly fast. But sometimes we don't know how big is the infection that we have. And a good way to do it, to monitor this, is just that we can use this card box roll like this one, and the day before and the day after we can open it, and we are going to see that there's plenty of adults and larvae, and this is going to help us to see how is the infestation of our farm and if a treatment, for example, has been effective or not. Because sometimes when we visit the farms with the light, this beetle is photophobic and doesn't like the light, and he hides in the walls, for example, and we don't see anything, but the infestation could be really hard. Well, this beetle can destroy all the isolation, and be careful with the feeders that are all the time wasting feed. I mean, we have to be very careful. Normally, this is one of the first sources of beetle contamination, that when the feeders are wasting feed on the ground. About the rodents, we have two types: active measure and passive measure. Really, the active measures, it's very important, but it's secondary, because we can use bait trap. We need to put this stick through the poison, because if we don't do it, maybe the birds can take it out. They can take it out from the box. It's common to see that there is no stick going through this poison, so we need to put it. But also we can use glue, always touching the walls, because the mice, they never run through on the corridor. They always run very close to the doors, to the walls. Sorry. And also, if we don't want to kill it, as in other countries, but in some countries they don't want to kill the mice, they just want to trap them. You can use methods like this one. I mean, the day before, you will see all the mice here trapped. Well, we have to have maps with all the bait traps. That's also really important. And the passive measures, that is what is really important, let's say. And for passive measures to control the rodents, one of the most important is to keep the doors closed and close hold. This looks like very simple, but it's really important, and this not all the time correctly done. We need to have no vegetation and material outside, and no feed leftovers outside the farm. For example, this is some extreme farms that you can see that they extend the wall under the ground to avoid the mice scratch and going under the wall. So this is something extreme, but it's been done also. Also, you see these metal plates that doesn't allow the mice to jump inside the farm. You see this protection? So it's also this different type of protection. But for example, in a farm like this, it's not possible to be in contact with birds or rodents. What we have to do is to work on them, to use foam or cement to close all the holes. And this picture, I like it a lot because it's very useful to have this, like for example, iron stick through the door to avoid the mice in some cases going under the door, because sometimes the doors are not really touching the floor. So this could be something really useful also. And in a picture like this, if we see a farm like this, I mean, the mice are going to be really relaxed and they are going to walk around without any problem. They can hide everywhere they want. Okay. What they are not really comfortable is in a farm like this one. I mean, you see, like everything is cemented around, and the mice are not, the rodents are not comfortable in this kind of environment. Okay. Well, here, for example, you can see the drains open, the doors open, they fit here, so that's terrible for that is going to attract a lot of the mice, and also the feed leftovers. And an interesting thing also is that the drains, when we clean the farm, is to close them with this kind of putty and this iron wool, because the mice, if we don't use this kind of thing, the mice can bite this kind of holes to drain the water, and they can get inside the farm. So try to close this type of hole with these two elements. Okay, that could be really useful. Also, to be protected with the from the wild birds, we can have to have really in good conditions the grills. The grills, sometimes there are holes on it, and to use this kind of structure like iron sticks to prevent them from doing some different type of nest. Okay. Also, this is a grill protecting a feed silo to keep the birds away from it. But for example, I take these two pictures because there are two common mistakes. One of them is that the silos are open. That also this sometimes is useful, but one of the most common mistakes that I see normally is that all the time the doors of the farms are open. In here and here, we have to be really careful, and our employees have to have in mind that the doors need to be all the time closed. Okay. Well, about farm cleaning disinfection, just 2 key points. Okay, just 2 key points because we don't have time. One of the key points is that we have to use a thick foam that is going to be in contact with all the dirt in order to take out all the dirt easily. Because if the foam is not in contact a minimum of time, it's going to be very difficult to get rid of the dirt. And the other thing is that in this type of feeders, for the males in breeders or in broilers, sometimes we do nothing. We leave it like this. From time to time, it's useful to use this kind of corn, like mashed corn, mixed with some type of disinfectant, and make pass through the auger, pass through the feeder, this combination. We can leave it there, and we are going more or less to disinfect the feeders. But we have to do something, because sometimes I've seen that this feeder has not been cleaned for many years, and it could be a problem also. Just to finish about a few risky practices, okay? The first one is the animal movement. I mean, once our birds are going to the slaughterhouse, we have to plan very carefully the way to the slaughterhouse. We have to do it very carefully. I mean, not to do it from one day to another, to plan the route of the truck, which people are going to be involved, if that people is going to go the day after to another farm, because normally the slaughterhouse trucks, they could be very dirty, and they can contaminate another farms or our employees also. And the other thing is the spiking males. You know what is the technique of spiking males in breeders. So we have to be very careful and to check the vaccination program. I mean, they have to have the same vaccination program than the farm that is receiving the old farm that is receiving the males, and also we have to test them from MG, influenza, MS, and salmonella, because these young guys can contaminate the farm where they are going. So we have to be very careful. Instead of spiking, we can use intra-spiking. we know that is less effective, but that is safer because we don't move animals from one another to another. We move just maize from one house to another house. Okay, about the disposal mortality methods, I mean, just to remark that we have to have one person in charge that is taking the mortality. We can do a daily incineration depending on the legislation of each country. For example, in this case, they have an incinerator where they incinerate the mortality every day, or we can freeze the mortality and inside the farm, and each week they take the mortality and they leave it in this type of containers where a specialized company is going to take all this mortality to the place to the correspondent place. So I mean, and this freezing the mortality sometimes could be very useful. Okay, in our farms. For example, in this case, we have 3 different farms, and there is a disposal mortality center here, and there is one person that is in charge of all the mortality, and each day, and 1 day per week, for example, it takes all the mortality from the farms to the disposal mortality center. Okay. So there are different ways, but we have to be very careful and have one people in charge. Also, well, it's something maybe not really important, but I would recommend you to have ready a plan for catastrophic situation. I mean, if we have a catastrophic situation, we have to act the day after, and we have to have written a plan because we never know what's going to happen. So at least to have a plan to manage this terrible situation. Okay, and just one slide more, and just about the staff, one slide. The staff must understand that if one fails, all fail. I mean, every employee has to understand the rules. Sometimes the employees, they don't understand the rules. So we have to train our staff and to make more or less to make it simple, more or less. Okay, we don't need really complicated biosecurity programs. If they are very complicated, we are not going to be able to follow them. So we need just one person to be responsible for biosecurity. If we have one person that is responsible of the biosecurity, we are going to succeed more than if we have multiple people giving their own idea. So we need to have one person responsible of biosecurity in each company. Okay, and normally the biggest problem is the staff relaxation. The employees, they get relaxed over the time, and this could be really a main problem. Okay, so we have to be all the time like checking what we are doing in our farms, who is not doing correctly, and this kind of thing. Because in the first moment, everything is very easy, everything is okay, but over the time, things are getting relaxed, and we can have a few problems. And as conclusion, just to say that we have to, for our farms, we need a correct design and location of the farm. This is one of the most important things. I mean, the employees must be engaged and trained. The company must have a culture of biosecurity, and we need to have everything recorded. I mean, we have to check that we are doing all the things correctly, and it's really important to pay attention to the details and to give them some importance. I mean, not getting to the farm and saying, well, this is not important, this could be done tomorrow. No, we have to pay attention and correct all the mistakes that we can see when we are visiting our farm. We have to check the behavior of our staff all the time. Again, if one fails, all fail. And just as it's almost as a joke, but probably this is let's say maybe the most common mistake I've seen in many farms, that all the doors of the farms sometimes are open. So we have to keep them all the time, the doors closed. That's it. Hassan, I hope to be more or less on time. I don't know.
Yes, thank you very much, Jaime. You were just on time. And we have 2 questions, one for Christophe and one for Guanel. So the one for Christophe, asking about the Christophe,
yes.
The signs and the lesions may be not classical in lesion and quails. Any comment?
Well, many bird species can be infected by avian influenza virus. So this virus is extremely widespread in many different species. However, what we know is that the susceptibility may vary according to the species. It has been much more, let's say, investigated in ducks, for instance, because of this migration and the risk related to migration, and to my knowledge, a little bit less in such type of species like quails and pigeons. So, however, in general, let's say in what we can call domestic bird species, the general signs and the lesions are quite similar. But again, you don't necessarily observe all the different signs that I presented. I tried to be as comprehensive as possible, but you may easily face only a few of them. But again, in other species, you can observe, I would say, the same type of hemorrhagic signs and septicemia and acute mortality. For instance, in France, we had some Guinea fowls, and the last time we had first cases in Guinea fowls before chickens, so it's possible.
Thank you, Christophe. So the coming question is for Gonal. Can you monitor and follow up the behavior of mutation of the virus in other strains, from which we can deduce the prediction of the impact of the virus in the region, or each virus had a different behavior?
Yes, so thank you for the question. First, I wouldn't say that each virus has a different behavior, because it's a virus that kills birds and that infects many species, but there are some slight differences between viruses. So now we have more than 15 years of experience with this virus, and with the bioinformatics tool and the sequencing, we are more and more able to look at the sequences and try to interpret the impact of a given mutation or groups of mutations on the phenotype of a virus. For example, if you have a specific mutation in the HA gene or NA gene, we can say that there's a higher potential to infect humans. Or if there's a specific mutation in the HA, we can say that the virus would have more chance of invading the respiratory tract. But as of today, we're still a bit too weak, because we are able to check the sequence afterwards. But the level of prediction is still quite low. With artificial intelligence, we will probably in the future be more able to predict a virus behavior just looking at the sequence. And I would like to state that we also need to become more able to anticipate problems. For example, problems and new strains usually start from Asia, and then the viruses would spread within Asia, and a few months after, I explained that it would be transported mostly through migratory birds to Europe, Middle East, and Africa. So we should be able to predict better when there's a new strain emerging, which is very active in Asia, and then Middle Eastern, African, and European countries should be better able to predict that the virus will come in 6 months' time. And these intercontinental waves could be predictive probably through weather forecasts and being able to integrate more epidemiological criteria. Over.
Thank you. AI can be transmitted by the air or wind or not? Is the AI can be transmitted by the air or wind, or it cannot be?
So as far as I know, there has been some experiments between chickens as well as between ferrets. You know, these small mammals, ferrets. And what I found in the literature is that we are able to achieve an airborne transmission by 80 centimeters distance, 80 centimeters, not beyond that.
Okay. So we cannot say it is airborne disease.
So it means that it is possible, and we also know, for instance, that slaughterhouses or live bird markets are definitely a place where we can get some contamination. So we cannot exclude completely the airborne transmission, but probably in a very close proximity.
If I may add, in the US and Canada, they also had some contamination between farms with days with a high level of wind, and because the virus can be transported by dust as well. So that was the only epidemiological link that they could find between those farms. There was a strong wind from a farm to the other.
Okay. The second question is why blue discoloration is noticed in throat and neck region in high-pass avian influenza. Okay. I think it was for Christophe.
I did not get the point, Hazem. Can you reformulate, please?
In some picture, there is a blue discoloration noticed in the throat and the neck region. As this is how to say.
I think, yeah, there have been, well, be careful that there have been some pictures of experimental infection. So some birds have got some staining on the back. That's it. The only blue color that matters was the one on the comb and the waters as a cyanosis, but not on the feathers. Don't worry.
So the last question is what are the differential diagnoses of Newcastle and avian influenza, especially for production drop and egg quality?
Well, as far as I know, it's nearly impossible directly by the naked eye to differentiate an abnormal egg due to HPAI versus velogenic ND. Both viruses, both type of infections can induce some egg drops, can induce some discoloration of the eggs, and obviously damage to the eggshell itself. So we need to go for further investigation in this case.
Okay. Is there any active case of high-pass avian influenza in the kingdom now? I think this is not for us. This is for Dr. Ali. هل في أي حالات إنفلونزا؟
ايوه انا شفتها السماعه. طبعا هناك في 3 اسئله. المسافات المعتمده بالمشاريع اللازم اللاحم هل يمكن توضيح منه؟ هل وزاره الزراعه لديها خطه استخدام اللقاحات في بعض المناطق لا زالت معدلات الاصابه؟ هل لوزاره الزراعه خطه لتقييم اللقاحات في حال افترض ذلك؟ طبعا السياسه المتبعه في المملكه هي السبام الاوت او الدعم لكل بؤر الاصابه للتاكد من ان الامور ماشيه بطريقها الصحيح. طبعا هناك مراجعه باستمرار لخطط الطوارئ ووفق المستجدات والمعدلات الوبائيه وكذلك خطوره الوضع، ولكن حتى الان نرى انه سياسه الاعدام الكامل لبؤر الاصابه هي السياسه الاجدى والمثلى، وخاصه لنا تجربه ناجحه عام 2007-2008 للقضاء على مرض انفلونزا الطيور H5N1 واثبتت فعاليتها، والحمد لله الوضع تحت السيطره بشكل كبير. المسافات المعتمده من مشاريع اللاحم يمكن توضيح منه هناك مراجعه ايضا للمسافات المعتمده، ولكن لانه المسافات هذه بين اللاحم والبياض والجذور والرماد وغيرها هي موضعت الا لتحسين اجراءات الامن الحيوي بين المشاريع، وفي حاله حاجه مراجعه تلك المسافات يتم اخذ ذلك بوجه الاعتبار. نشكركم جميعا على حضور ومشاركه بهذه الندوه، اشكر جميع المحاضرين، اشكر شركه ماس للخدمات البيطريه، شركه سيفا ايضا، شكرا لجميع المحاضرين. نتمنى إن شاء الله بإذن الله نلتقيكم في ورش علمية أكثر وامتداد لشراكات أكثر مع القطاع الخاص. شكرا لكم جميعا وجزاكم الله خير.
الشكر موصول لك دكتورة. شكرا.
شكرا لكم.
شكرا جزيلا، حياكم الله.
شكرا. Thank you very much.
Thank you.
Thank you, everyone.
Thank you.
Christoph. Thank you.
Thank you.
Have a nice day.
Thank you.